Okay, Georgi Dinkov, aka / hate it. Thank you so much for joining me. We were just talking about how Ray makes his coffee, or rather his milk, which in an interview with Joe Dell, he kind of talked about it. So for any hardcore Ray nerds that enjoy milk, it's mildly interesting. Anyways, thank you guys so much for joining us on this Friday evening. It's so fun to do these, and the response has been overwhelmingly positive. And so, again, I just can't emphasize how much we appreciate the audience, the comments, the likes, the subscribes, and it really has been kind of something I've been looking forward to. So, sincerely appreciate it. How do you feel, Georgi?
Same way. I think I really like the new venue. I like the YouTube channel and like the technology in general. I've been watching the subscriber count grow, and I think it's good for us that we have I guess a more of a general audience, right? Because with the Patreon and even the previous podcast was more or less people who are hardcore Petarians, while probably now we're gonna get people who are come from different backgrounds. Some of them may be critical of the idea, so I kind of like that. It's a challenge. So it's good to be exposed to different views as well.
Totally agree. Let me just switch the screen here. So a few housekeeping things that I just wanted to talk about was, if you're new, consider subscribing, obviously. And we've been doing these every other week, Fridays at 6 p.m. PST. All super chats are donated to Raymond Pete. And again, that was Georgi's idea. And let me just flash on the screen here. So I've actually, where did I put it? We've raised like $156. I think that's without like Google tax for Ray. So I think that's pretty incredible. So thank you guys so much.
That's awesome.
And that's like pretty much a drop in the bucket, and that is from the first two streams, and then the Kyle one, and then our this one, obviously. But I have to send a letter to AdSense to verify my address to be able to obtain this money. And so that will take a second.
You're going to verify your address in Mexico? They're going to accept that?
Well, I have like an American address, like a mailbox, basically. Hopefully they do accept that. If people are bugging you in the chat, please block them. Like, users can block people in the chat, because I'm probably not going to block anybody unless they're like psychotic. And then I don't think really the mods are heavily blocking people either. And then I don't know about you, Georgie. I'd be interested in your take, but I've received lots of people saying that they just totally don't get what we're talking about. And that's like, I think that's fair enough, but we have a long list of backlogged podcasts. So if you type in the Generative Energy Podcast, a majority of the episodes are you and I. And
Right.
so I think if somebody were really confused, they could go check out those older podcasts. But this whole channel is trying to basically clarify these concepts. And when I'm talking to you, I think we're just trying to riff back and forth. And I'm trying to, at some level, to make things easy so I can understand it, but so yeah, there are resources online, and I think it's always the person's duty to try to find the resources and make them useful, And on that note, if you go to bit.ly/RayPete resources, that's a link to a tweet that I put up a while ago of just like the Ray Pete email wiki, which I think is like one of the most useful web pages on the internet, of people sending Ray messages and then him replying.
Right.
I like ad nauseum try to talk about these resources people can use, because I know everybody's coming from different points of view about health. Anything you want to add to that, Georgie?
Yeah, I guess maybe we can do like a quick 30-second recap at the beginning of every episode to say, look, so the difference is here's what we're doing.
I'm way ahead of you. I want to do that just in like 1 second. Is that okay?
Okay. All right.
But
so I have nothing to add then.
we're extremely on the same page. Okay. And I just want to announce the winner of the Tocovit. So Tocovit is ID Labs Vitamin E, and it's George and I talked about it last time, but do you just want to give a quick elevator pitch?
Yeah, it's extracted from wheat germ oil. All of the oils have been removed except for the very long chain saturated alcohols known collectively as polycosanol. And Pete talked about the old type vitamin E that he's been using and he saw used in the 50s, 60s, and 70s. And he worked with during, when he was doing his PhD thesis, his advisor was using it. And he's been telling people that, since maybe the late 70s, he's never seen any other product come close to what he saw used himself during that time. And he thought that basically, the fact that it was extracted from wheat germ oil and had these polycosanols inside, that was his guess was that that's what made this vitamin so potently anti-estrogenic, anti-hypoxic, anti-fatty acid oxidation. So basically, people have been complaining to him that they don't get the same effects. And his response was, well, none of the products that I've seen commercially available right now come close to what I've been using in the 60s and 70s. So I just wanted to try to replicate that. So I found a vendor that basically sells semi-concentrated vitamin E, a wheat germ oil, right? And then I take that and I give it to a lab where they basically do a distillation and supercritical extraction process with CO2, and they separate the liquid into the lipid components, the vitamin components. They call it the non-saponifiable because they cannot be turned into soap, unlike fat, right? And then the polycosanols, which are also non-saponifiable. So they do some analysis and then they merge it back, and that's what becomes Tocovit. It's basically nothing but mixed tocopherols, heavy on the alpha isomer because that's the predominant isomer in wheat germ oil, and then the polycosanols. Nothing else. We just add a little bit of medium chain triglycerides to make it flow a little bit more easily out of the bottle because otherwise it's impossible to squeeze out.
Sweet. And so we started doing a giveaway the last time we were together, and I put all the comments in a random generator on the internet. And the winner was Miles Rouleau. So I think it would be best if Miles, hopefully he sees this, and he emails me, Danny@DannyRoddy, is that my email? .com, and I could link up with Georgie, send the address, and Georgie could send out the Tocovit. And of course, we're going to do another one of these. And so all you have to do is subscribe to the channel, like the episode, and leave a comment. And the comment can be whatever you want. So thanks, Miles. And also, I don't know if you perused through the comments, but like Miles was he left a super nice comment, and then we received like a ton of really nice comment. So it was really cool to read, and so I appreciate everybody's just support in general. Okay. So here was my. You can't see it, Georgie, but I have a glycolysis versus oxidative metabolism and fermentation, and so yeah, this would be a perfect time. Like if we really should do this every single beginning of the episode, just so people understand where we're coming from, and all the information that we're going to talk about is umbrellaed under this energy concept. And George, do you want to take that?
Yeah, I was actually going to start even like a step earlier to kind of introduce and say, look, like most of the health topics you've been hearing, and even like the medicine you're getting from your doctor, is based on a 100-plus-year-old idea that you are nothing but the product of your genes, and everything that is wrong with you health-wise ultimately comes down to some kind of a either a genetic mutation or an expression of a gene that's really not beneficial for you, and then basically that's why you develop some kind of a pathology. And even though it used to be a very heavily genetic idea to the point where the doctors were saying environment doesn't matter at all, right? It's just your genes and nothing else. You're completely this isolated organism and only your genes matter and nothing else. And now little by little being forced to agree that environment does matter, but they still call it epigenetic, just to keep emphasizing that your genes are still involved. They're still at the core. And it's really just the environment activating or silencing certain genes. And then, so this is basically the mainstream view that you're getting from most of the blogs, most of the health resources, and especially from your doctor and the official health authorities. And our view is, unbeknownst to most people, there's been a competing view, and this is, I guess, the second dominant view, the second most dominant view is that the organism is a much more malleable set of cells, and it's really not so much your genes as it is the environment and the organism continuously interacting with this environment that determines whether you're going to stay healthy or not, and what disease will develop, and how this disease will play out. So in fact, this theory states that the organism cannot be separated from the environment. You're an integral part of the environment, and the environment is an integral part of you. So any question of health ultimately comes down to a question of some sort of suboptimality in the environment. That's all we are. We are environment adaptive machines, and health in general can probably be defined as mustering up a sufficient energetic response to an ever-changing environment. For as long as that is the case, for as long as you can muster up that energetic response and adapt to the changing environment, things are going well, right? Nothing is really, very, very negative, very, very bad for you. But once this energetic response starts to falter, when you cannot muster up the proper energetic response to the stimulus that's coming from the environment, then you start getting these, negatively adaptive processes, and ultimately pathology develops. So our goal here, not so much the goal, but the topic will always be the environment posing a challenge and the organism responding energetically. And then when the pathology develops, the question ultimately will always come down to where in this in this energy producing cascade, where exactly is a problem occurring, and what can be done to remediate it.
Ray says it you said it very well, but Ray in his Mind and Tissue book says, in a sense, the environment is a completion of the organism. And then your nutrition and all the things you've been exposed to are part of the environment. So people will be like, well, what does the environment mean? So, I guess
existence, just like he said in another email, what we call life is basically our reaction to an existence that is just a property of matter. And the way we interact with this reality, that's really what constitutes life.
Beautiful. Thank you for that, George. I'm glad you reminded me to do this. But do you want to? So our first article, controversial: sterilizing the gut may treat heart failure.
Oh yeah, I love that article because the people, like the authors of this article, really don't mix words. They call it out directly. I mean, if you look at the title of the article in Science Daily, they say wiping out the gut microbiome could help with heart failure. So basically, what they did is they took these mice and they gave them certain toxins that produce heart failure. And then I don't know how they decided, but I guess this idea is starting to really is starting to gain momentum. But they decided to see if endotoxin is somehow involved in heart failure because previous studies have shown the involvement of the TLR4 receptor, which is the endotoxin receptor. So they said, okay, let's see what happens if we basically get rid of endotoxin completely. And since it's produced by the bacteria in your colon or anywhere in the GI tract, they just gave these mice in a cocktail of antibiotics and made their guts completely sterile. And it almost completely eliminated the mortality from a condition that once it sets hold in a person, I think the estimated lifetime of a person with heart failure is 3 to 5 years. There's nothing available to stop it. There is nothing available to reverse it. The only thing that you get is basically quality of life management, blood pressure medication, and things that basically allow you to live the remaining of those 3 to 5 years as well as possible, right? As pleasurably as possible. And now these people are saying, no, not only it's not irreversible. I mean, we can completely stop the mortality, right? So these people can actually live, their life expectancy would be the same as for somebody who didn't have heart failure. Now, they couldn't completely reverse the pathology. So in other words, there was still some heart failure present, but in 40% of the mice, it completely disappeared. So fibrosis of the heart, which is what heart failure is apparently completely reversible in at least 40% of the cases if you completely eliminate endotoxin. And speaking of heart failure and endotoxin, Pfizer, unbeknownst to many people, is currently running trials with a serotonin antagonist drug, specifically on the receptor 5-HT2B, which is known as the receptor that's required for the development of fibrosis. So endotoxin and serotonin have a really intimate role. Endotoxin triggers the production of serotonin. So ultimately, heart failure is likely a serotonin-driven condition. So they just, they managed to reverse it in 40%. But my guess is that in the remaining 60%, you could have also reversed it by using that drug that Pfizer is running clinical trials with. It's called tergoride. Very similar. It's actually the hydrogenated version of lisuride, which is similar to bromocriptine or ultimately to LSD. All of these drugs are LSD derivatives. So I wouldn't be surprised if at some point, people start treating heart failure with LSD. And now it reminds me that actually the generation that is known to be among the heaviest users of LSD, the hippies, they actually have the lowest incidence of heart failure. That's probably related.
I feel like the immediate question about sterilizing the gut is like, what about the commensal good bacteria? So like what is your perspective on that?
And I posted another article on that where they actually looked at cancer. It was both liver and pancreatic cancer, and the authors of that study, in their own words, said there is no such thing as good bacteria. If it produces endotoxin, ultimately it is not good for you. I guess there are just degrees of how less pathological a bacteria can be. Now, clearly, something like C. difficile, which can kill a person because they have such severe diarrhea they can't really hold down any food. It's probably more dangerous, more pathological than something like the lactobacillus strain that people are gobbling up as probiotics. But even that bacteria is capable of producing endotoxin. So ultimately, the goal should be limiting the amount of endotoxin produced and or the exposure to it. And basically, if you don't want to wipe out your microbiome with these heavy antibiotics, then I guess the second best solution would be limit to how much endotoxin gets into your blood. So, Ray has been recommending the carrot salad, the bamboo shoots. I personally really like charcoal, and he even talked very favorably of charcoal, but for some reason he thinks that the currently available products on the market are likely not safe because it's about the size of that carbon molecule that comprises the charcoal. He thinks that some of them can get into the bloodstream and cause an allergic reaction. But some of the older studies that he cites in his articles show that if you add charcoal to the feed of pigs that are really close to us organ-wise and physiology in general, if you add charcoal to their diet just twice a week, it increases their lifespan by 30%, and it makes them free of many of these fibrotic diseases that we're seeing nowadays, like cirrhosis, heart failure, pulmonary hypertension, which is also related to serotonin. So yeah.
Just as an anecdote, how if endotoxin is a problem or whatever, like I think in general, lower thyroid people will be prone to constipation. And whereas if you have like an abundance of bad bacteria in your intestine, you're more likely to have diarrhea.
That's right.
And so I think, again, just my own anecdotal experience, I was having diarrhea like pretty much chronically, like, and it didn't really matter the types of foods I was eating. And so that kind of led me down this road of trying an antibiotic. But since then, and again, I don't know if this would be for everybody, but like there would be some mysterious symptom and I'd take 30 milligrams of penicillin or something and the mysterious symptom would go away. And again, I don't have perfect data on this, but I would think to myself, wow, I can't believe that symptom could have been related to endotoxin or the cascade of nitric oxide or serotonin or whatever. But yeah, it's I think there's a reason when somebody calls in to KMUD when Ray is on there and they're like, I have PMS, menopause, depression, insomnia, all these different things. And he's like, oh, have you tried the carrot salad? I think like it's because endotoxin can have such a profound effect, and also serotonin, obviously. But if you're thinking about the thyroid, I think you have to obviously think about the liver and then the intestine. And those are actionable things that I think you can really start moving in a good direction once a person is using various therapies to support those different systems.
Yeah, many people actually, I feel like they're not taking Ray seriously when he says they call him with such serious problems, and he's saying, "Well, have you tried the carrot salad?" Reminds me of his article when actually I think it was in the early 40s. There was just this small attempt by doctors to tell people to take aspirin for cancer, and the response was overwhelmingly negative. People said, "Are you kidding me? You're my doctor. I'm asking you, what's wrong with me?" And you're like, "Take aspirin, call me in 6 months." Like I may not be alive in 6 months.
Well, he said towards the end of his aspirin article, like when people ask him what they should do for cancer, he often says like 10 or 20 aspirin, and they think he's joking.
Yeah.
So they don't do it.
Yeah, they don't do it.
And so there's like a cultural prejudice against using aspirin. Sorry, keep going.
Yeah, I mean, to people who are really like who think aspirin is it cannot be used as a serious drug, just keep in mind. Recently, an article came out in Bloomberg where the head of one of the biggest pension funds in the United States wrote an op-ed and said, "Oh my God, aspirin is really going to ruin the pension system because we think that it has such serious both preventive and curative potential in cancer that all of these people that were hoping would die, they wouldn't die because, even if they get cancer, aspirin will treat it, and many of them will not get the cancer because they're taking aspirin. So our pension system will collapse." So the big money is freaking out that aspirin works for cancer. So usually, the saying, bet on whatever big money is betting. Well, they're betting that aspirin works. So if you're going with the flow, then really that's what you should be doing. You should be considering aspirin for cancer.
Since you brought it up, can I divert the conversation a little bit? Can we talk about iron for 1 second? Because
sure. The
last week or two, I finally gave blood in Mexico, and it's something I normally would do in San Francisco. And I was like shocked how good I felt afterwards. So I must have had some kind of accumulation of iron, because I guess like I'm kind of wishy-washy with the coffee with the meat. Like I think I'm more drinking, as long as I'm drinking something with coffee versus having like a full cup, which I know Ray has recommended. But I felt so good after the blood donation. Iron overload is so involved in so many different problems, hypogonadism, which people are talking about, is ad nauseum. And then I found a reference that said the principal target of the iron overload is the liver. And like how many threads have you seen on liver health? And to me, it felt, I know I'm going to sound a little kooky saying this, but it felt a little anti-serotonin. Like I felt like I could think clearer, and I was just more motivated to do things I normally for the past few weeks, like I haven't been motivated to do. So again, it was not because in Mexico, nobody's barely ever heard of iron donation. It kind of reoriented me of thinking about it. And I know that Ray says that iron donors are usually healthier than people that don't donate iron, but I also know Ray well enough to know that I don't know that necessarily means go give blood. And so I just wanted your perspective on it, really. Well,
I think it's very easy to do a few blood tests, get the iron panel done, and figure out where you stand on iron. So people usually go to the doctor and say, taste my iron, they get the serum iron, right? Mm-hmm. That usually means nothing unless there's a really like your iron is like sky high or like it's not even detectable in the blood. That's the only time when iron is useful. But you can have normal serum iron and still be actually either iron deficient or iron toxic. So in addition to the serum iron, you should always be getting the transferrin, the ferritin, the total iron binding capacity, and the iron saturation index. So if your iron saturation index is above 30, you can probably use a little less iron. So whether you restrict a little bit in the diet, or you donate blood, or take things like aspirin or vitamin E. These things are known to chelate iron. Milk is actually probably one of the biggest dietary chelators of iron.
Lactoferrin, right?
Yeah, because of the protein lactoferrin. So basically, if your iron saturation index is over 30, chances are that you can use less iron if you looking to get more optimal health. The only people that really thrive on iron are very young children, and because iron is so intimately involved in growth and division. Because of their high metabolism, children can actually restrain that growth or channel it in the proper organs. They can differentiate that growth and become healthy, normal humans, adults. But we as adults, we can actually use less growth. We've already grown, so it's the goal is to mature and continue differentiating, not revert back to that uncontrollable growth state, which is fetal development / neonatal and or cancer, right? And I wanted to say, like, one of the reasons you may have felt that serotonin was involved is because iron is actually known to stimulate the enzyme tryptophan hydroxylase, which synthesizes serotonin from tryptophan. Mm-hmm. Now, it also stimulates the tyrosine hydroxylase, which synthesizes dopamine. But unlike tryptophan hydroxylase, where you always have an excess of tryptophan available, and as soon as you activate the enzyme, it starts pumping out serotonin, dopamine synthesis is more fragile. First, it depends on copper as well, right? And then also it depends on the availability of the amino acid tyrosine. And most people who are high on iron are actually copper deficient. And so that's another reason to consider maybe bringing your iron numbers a little bit further down, is because the more iron you have, the less copper you'll be able to use. So you can actually load yourself up on copper, but the transport of copper depends on a protein called ceruloplasmin. And people with high iron tend to underproduce that protein. So when they're loading up on copper from diet or supplements, that copper cannot be utilized. So you can give yourself symptoms of copper toxicity while still being actually deficient in it. So really the way to go is, like, if test your iron, do the full iron panel, and if you have the iron numbers higher than let's say the lower 25% of the normal range, you can probably deal with a little bit less iron, and by various means: dietary restriction, chelation, giving blood. And then, just like you said, sometimes you can have a dramatic, very quick response, and whether it's because serotonin is lowered or whether because you're allowing copper to actually do its work. Could be a number of different mechanisms, but we know that iron excess is intimately involved in aging, in producing the lipofuscin, which is like now known to be able to block mitochondrial function in any organ, and also in cancer. If you go on PubMed and search for iron chelation cancer, you will see that over the last 10 years, there's been an explosion, because PubMed also gives you this graph, like, how many studies contain the search terms that you search for. Mm-hmm. And iron chelation in cancer wasn't really popular in terms of studies being published until I want to say early 2000s. And since then, there's been an explosion of published studies, and they're using this iron chelator known as desferoxamine to treat now leukemia, lymphoma, pretty much any myeloproliferative disorders, which are the hematological cancers. And now they're saying they think it may also work in brain cancers like the neuroglioblastomas, really aggressive and lethal cancer, even in pancreatic cancer. So little by little, these studies are basically patching the work and saying, look, it looks like most people actually have too much iron, right? And especially in something like cancer, iron can be really detrimental and lethal. So the less of it you have within limits, the better for your health.
Yeah, and why make something so complex if it's something simpler? Right. And like the PUFA accumulating over time, iron is something that could presumably easily accumulate over time. And then I haven't dug super deep into this, but in one of Ray's fairly old newsletters, and I think he said this in newer ones too, But he talked about like hypoxic areas specifically accumulating iron. And I emailed him years ago, and he was saying that the hormones were largely in control of iron, and that's why in menopause women like rapidly accumulated iron. So again, it'd be interesting to pick his brain on it a little bit more. Like, I'd be curious if he did regular donations, but you're right. Knowledge is power, and you should get the iron labs, especially the iron saturation and stuff. I have Valtsu Vladimir Heiskanen's Finnish genius, his article up. It's called Copper, the Forgotten Essential Nutrient. And I know you posted a lot about copper as well, but beef liver, oysters being some of the best sources off the top of my head. Squid, I think, too. Some of the things.
Pretty much any seafood will have it because in some of the sea animals, it basically like their blood is based on copper, not on iron, right? Especially in crabs. But in general, seafood tends to be richer in copper and less rich or even deficient in iron. So any seafood you get, make sure if it's fish that it's not fatty fish, and if it is fatty fish, then it's from the tropic regions because then the fat will be more saturated. And if you're eating, cold water fish, then in my experience, the only safe one is either cod and I think tuna. But tuna has to be if you're getting the canned tuna, make sure it's not in oil because they usually use soy oil and it's almost always PUFA. So either tuna in water and salt, right, in brine, or if it's basically oil, make sure it's olive oil or some other oil, and look at the label because now they're starting to list the breakdown of the fats as well. Used to be just total fat and like saturated fat, and now they're starting to do total fat, saturated, polyunsaturated, even monounsaturated fat. So that will be my take. Seafood is good, but just make sure it's not fatty. And if it is fatty, then it's from the warmer regions so that the fat is saturated.
Sole, I think, is another low-fat fish.
Sole, yeah, exactly.
Okay, great. Sirtuin is a key promoter of leukemia and other blood cancers. And this is somewhat related to resveratrol, right?
Yes, exactly. I don't know how many people have read. Ray has an actual newsletter specifically dedicated to resveratrol. I think it was called the resveratrol scam, right? So I think it was around 2004 when resveratrol kind of hit the news, and most of the research behind resveratrol and also the sirtuins, because they're intimately involved. Resveratrol was promoted as one of the most potent activators known of these sirtuin genes, right? And basically this guy called David Sinclair, I think he's a biologist and used to work at Harvard. I don't know if he still does, but I'm pretty sure he still maintains some kind of a relationship. He put out most of the research out there in the early 2000s that was available on sirtuins and resveratrol as an activator. So he basically started claiming that, activation of these sirtuins is something that protects from virtually all kinds of chronic disease and specifically extends lifespan. So he did a lot of studies with mice in his lab, and he started claiming that, activating sirtuins, and especially Sirt1, I think there's three of them, Sirt1, Sirt2, Sirt3, activating the sirtuins is what really led to the extended lifespan of his mice, and they weren't getting any cancer, they weren't getting diabetes, they were healthier, and they stayed healthy all the way up until they died. So somehow the public ate up all that research, and then Mr. Sinclair formed a company called Sirtuins Pharmaceuticals, from Sirt, I'm guessing it's named after the Sirtuins. And the goal of this company was, it was marketing a patented version of resveratrol, which Mr. Sinclair developed while he was at Harvard, and then they wanted to do clinical trials with humans. So that company was bought by GlaxoSmithKline in 2008 for the whopping amount of $720 million. I don't know how much went to Mr. Sinclair, but I think most of it did because it was the ownership was split between him, Harvard University, and I think one other person. So wow. He must have been a multi-millionaire after that. Within a year of this company starting to do clinical trials, it was shut down because the active group that was actually getting the resveratrol, the patented resveratrol, started experiencing deaths. And I think they were basically some of the studies were for some blood cancer. I forgot what it was. And people started dying from kidney failure. So trials were immediately shut down, and the whole company was actually shut down. So GlaxoSmithKline took a $720 million write-off, but more importantly, it turned out that this is a non-starter. This whole thing of activating the sirtuins, as far as cancer is concerned, at least, it's a non-starter. Mr. Sinclair continued to promote his research, and it looks like he's slowly starting to come back, but now with different chemicals. But the goal is still again to activate the sirtuins. Now, the newsletter that Ray put out basically said, look, it's actually very simple. The sirtuins are heavily involved in promoting fatty acid oxidation, and niacinamide is actually an inhibitor of the sirtuins. So you can think of niacinamide as an inhibitor to resveratrol. Mm-hmm. Now, all the research that we have so far that's been done by multiple people over hundreds of years, none of them funded by industry, shows that niacinamide is overwhelmingly protective in almost any condition you can think of. And all the research we have on the sirtuins and resveratrol mostly came out of Mr. Sinclair. Mm-hmm. And a small amount of research came out later, but they all quoted his research and basically assumed that his research is correct. Mm-hmm. So, but what the evidence is that whenever activation of sirtuins was tried, it killed people. And whenever niacinamide was tried, it didn't kill people. In many cases, it helped them. But the reason I post this because, even Ray's article at the time made the connection between chronically overactivated sirtuin genes and cancer. But I don't think the newsletter made the connection directly. Only subsequent research showed that if you activate SIRT1, you're dramatically upregulating fatty acid oxidation. And as we know from previous studies, that cancer is actually almost like an extreme diabetes. It's a disease that has gluten for fat, not for sugar. Mm-hmm. It actually wastes the sugar, converts most of it into lactic acid, because while fat is being oxidized due to the Rendell cycle, you can oxidize the glucose. You're wasting is lactic acid. And whatever little amount makes its way through the pyruvate dehydrogenase and gets into the mitochondria, gets immediately converted to fat through the fatty acid synthase enzyme, and the cancer oxidizes that, for fuel. And protein, the same thing. The cancer basically strips you of your muscles and tissue and everything else, converts these amino acids to glucose, then converts that glucose to fat and oxidizes fat. So cancer has been shown at this point to be a disease of excessive fatty acid oxidation, and doing anything that even mildly inhibits that fatty acid oxidation has been shown to be hugely, hugely therapeutic. And guess what? Activating the sirtuins actually promotes the fatty acid oxidation. And studies have started to come out lately showing that, look, the SIRT1 is really, we should be careful with it because, there is some research that it extends lifespan, but all that research came out from one person, right? And then now we know that, for some reason, they're still not making the connection with the fat oxidation, but because it's such a fashionable topic. You need to burn fat to lose it, right? But even mainstream medicine is starting to wisen up that activating the sirtuins is not a good idea. And this specific one showed that SIRT1 is required for the beginning of leukemia, for cancerization, and for its progress. And the animals that had that gene deleted or shut down, not only, first of all, they didn't develop leukemia, and if they did develop the leukemia and then that gene was shut off, then basically in some cases the cancer either went away on its own, or they were actually much more amenable to treatment with the whatever toxic chemotherapy the doctors try to throw at the cancer. So activation of the sirtuins, and specifically SIRT1, is not a good idea. And niacinamide is the clinically defined standard for inhibiting SIRT1.
This is from Otto Warburg's 1927 paper, The Metabolism of Tumors in the Body. And he goes, even if it were possible to remove the blood sugar entirely in living animals, the life of the tumor would not be threatened. Do you want to expand on that a little bit? Because I think hearing that sugar or cancer rather is this fat loving physiological state, flies in the face of that quip you always hear that cancer lives on sugar, which I think is really maybe a misunderstanding or maybe a deliberate distortion of Otto Warburg. And so I think that's where it's coming from.
Yeah, and also I think one of the reasons this whole confusion started is because they're looking at diabetes and saying, oh, look, diabetes is actually a disease of excessive sugar, and if you restrict sugar, you'll be curing it. So for some reason, sugar is being demonized, but medicine is so focused on the symptoms, and because they don't understand the underlying dynamics, they're still thinking of genes. All they can do really is talk about the symptoms, and they're seeing, oh, diabetes, sugar cannot be metabolized, so we should remove it, right? Well, how about you figure out why it's not being metabolized instead of restricting it? Where did this assumption come from that if something cannot be metabolized and you remove it, somehow the pathology will disappear? This is still symptomatic treatment, right? And then, but the other thing is basically that, so they're seeing that cancer cells have this they call it voracious appetite for glucose. Well, of course they have a voracious appetite for glucose because they rely on glycolysis almost entirely for survival. And in glycolysis, you can only metabolize glucose. But since glycolysis is so inefficient to produce the ATP necessary for the cell to survive, you're going to need an exorbitant amount of more glucose just to keep the cell alive. So that's really what they're seeing on the MRIs, this huge uptake of glucose into cancer cells that gets turned into lactic acid. That doesn't mean the cancer thrives on glucose. It's just a cell that is stuck in such an inefficient energetic production mode that it needs more resources to produce the same amount of energy. It's similar to I guess the comparison would be like the old coal plants and then like the newer plants that work with fossil fuels. What was the expression like? So there's like almost like a return on investment. Like you need to burn a ton of coal to produce, let's say, like 1 watt of energy. That's what happened. 1 kilowatt of energy. That was back in let's say the 1910s. And nowadays, if you burn the same amount of coal, you're gonna get like 10 times more energy. So the same analogy will be applies to the cell. If the cell is healthy, it's like the newer reactor where it's basically optimally processing the raw materials and turning them into energy. And if the cell is cancerous or diabetic, it akin to reverting to an older technology, which is actually exactly what happens because glycolysis is an earlier evolutionary mechanism that evolved before the mitochondria. So basically, the cell reverts to the older type of coal plant of the energy production plant. And so what this means that let's say that if the cell needs to still produce 10 kilowatts of energy to survive, then this means that it needs 10 times more energy raw materials to produce the same amount of energy. That's why you're seeing all this sugar going up and being uptaken by the cancer cells. It's not because they love it. It's because they can't process it properly, and they need that much more in order to survive.
Ray said something really similar to what you just said. I forgot what it was called, like burning a torch of a pure flame or something. Do you know what the proper names for those things?
He basically, I think he said like a candle. And basically, he's saying that similar to if the candle is burning really well, there's very little smoke.
Yeah.
And now basically, if the candle is not burning well, there's like humidity. If something is interfering with the oxidation of the candle, turning it into basically this organic material under the influence of oxygen, you're going to start getting smoke. Anything, it doesn't have to be humidity. Anything that interferes with the combination, with the oxidation process, really, because that's what a candle does, is going to generate smoke. So he gave the same analogy for the cell. Anything that interferes with the oxidation of food into carbon dioxide and water, and ATP, of course, will generate lactic acid. And lactic acid is the equivalent of the smoke. And it's been shown that in the case of the candle, if you cover a candle and make it like in a hermetic, like a airtight area, and if you start adding smoke to that area, that will actually little by little extinguish the flame. Same thing happens with lactic acid. If you have a buildup of lactic acid, it's not just a bad byproduct of inefficient metabolism. It's a metabolic inhibitor itself. And recent studies came out, which I think you saw, I sent them to you, like there was discussion on Reddit, and then they said the Warburg effect, which is the wasting of glucose into lactic acid, is not really an effect. It's actually as much of an effect as it is a cause of the cancer. It's lactic acid itself that is carcinogenic because it inhibits the metabolism of other cells, not just of the injured cell or sick cell that produced it. It has a field effect, which is systemic. I mean, of course, it first starts just in the localized tissue, but injured cells, they start sending signals to every other cell in the body, and the signal is mobilize resources and help us. And little by little, it basically besets the entire organism if it's not rectified.
Just before we move on, so this is another quote from Warburg. And he says, just as there are many remote causes of the plague, heat, insects, rats, but only one common cause, the plague bacillus, there are a great many remote causes of cancer, tar, rays, arsenic, pressure, urethane, but there is only one common cause, into which all other causes of cancer merge, the irreversible injuring of respiration.
Yeah. And I think the part where Ray disagrees with Warburg is that Warburg thought it's irreversible. But several studies have come out recently show that the cancer cell can perfectly be reversed into its normal condition. It's not damaged in any way, despite the mutations. Actually, it turned out the mutations came as a result of the metabolic derangement. They weren't a cause of it. So if you basically create a quorum, a good environmental quorum that can overwhelm the cancer field, the field which is, oh my God, we are dying, we can't produce enough energy, give us more raw materials, give us raw. So if you can overwhelm that quorum with a good signal, cancer cells immediately revert back to normal. We just don't know that well yet how to control that signal, but there are tools that have been shown to help in many specific cases, in the first one is inhibiting the fatty acid oxidation. It comes down to a very basic thing. Oxidizing glucose is both a state of health and also a signal to every cell in the body that things are going okay. While oxidizing fat, on the other hand, is just a very primordial signal. Just if you think about it, a starving animal will probably oxidize mostly fat. That's the purpose of the fat in the body as a storage. It's you oxidize it when no other food is available. So it's quite logical and plausible to think that once you start oxidizing fat, maybe that is a signal for the body that things are not okay. So it changes the way it operates in order to accommodate for this suboptimal environment.
Well, on that note, let me briefly pause just to let everybody know any super chats you put in the chat box, those are going to go to Ray Pete. And I mentioned at the beginning of this that so far through the last 4 live streams, we've accumulated about $150 for Ray, which I'm going to send him as soon as my AdSense account gets approved. So thank you guys for that, and I'm sure he'll be happy. I'm going to screenshot all the people because that do the super chats and send that to Ray. So it's not on my behalf that I've done that. So thank you guys, and then thank you to the moderators, specifically Steph, who's amazing. So thank you guys, and Dan, if you're there, I don't know, but you guys are awesome. Thank you guys so much. I sincerely appreciate it. Well, speaking of fat cancer, do you want to go into the increased fat oxidation does not lead to fat loss?
Yeah, so that's another thing which I think you and I have been discussing since 2015. Actually, before I jump on, I just wanted to mention a study which we may have discussed last time. I don't remember. It was about metformin and the cancerization. So we just talked about how the Warburg effect is really not just an effect, but it's also a cause of the cancer. Mm-hmm. And that study that came out maybe 2 weeks ago showed that acidosis, in other words, the very fact of wasting glucose into lactic acid is a sufficient and necessary condition to trigger cancer. You don't need anything else. I mean, of course, just like Warburg said, it could be multiple other reasons like radiation or toxins, but ultimately the metabolic signal that apparently triggers the cancerization, if it's going on chronically, is simply acidosis, simply the generation of lactic acid. And the reason I wanted to mention is that they found out that they can actually trigger cancer by administering one of the most popular drugs that is being given to everybody these days, and metformin. It's the drug for diabetes.
Anti-aging drug, you mean, right, Georgi?
Yes, the anti-aging, the promising anti-aging drug that is billions of dollars of taxpayers' money are being poured into these anti-aging institutes. I think they're out in California and Boston to basically study how metformin is going to prevent every disease out there and make us live to 200 years. But guess what? That study said, nope, we actually use metformin to cause cancer. And actually, when we gave it to animals with cancer, it killed them much quicker. And the mechanism was this acidosis. So speaking of the acidosis, jumping onto the increased fatty acid oxidation. So just as we mentioned, there's the Randall cycle, right? And they mentioned the Randall cycle in that study on increased fatty oxidation. So most people think that, okay, so if I'm overweight, this means I have too much fat on me. And the only way that this fat can go away is if it gets turned into energy, right? So people just, kill themselves with exhaustive exercise. They go on these calorie-restricted diets. Of course, they restrict sugar because guess what? If you don't restrict sugar, you can't really burn the fat, which is technically true, right? You'll be burning less fat if you're actually eating, a sufficient amount of sugar. But it's been shown that actually, first of all, increased fatty acid oxidation. There are multiple studies. As this study itself says, that it's very controversial. A large number of studies show that increasing fatty acid oxidation may actually trigger insulin. Remember that study we discussed in the previous podcast that fatty acid oxidation triggered liver insulin resistance?
Yeah. I think that was the last time, yeah.
Yeah, so basically, at the very least, increasing fatty acid oxidation may damage your liver, which is the first step to developing type 2 diabetes or some kind of a bad liver disease. And this study now says, guess what? Let's put aside the damage that fatty acid oxidation does. You will not lose weight if you increase fatty acid oxidation. You know why? Because of the Rendell cycle. So apparently the body, which should have been obvious to every doctor, but I don't know why it isn't, has a homeostasis. So when you increase the fatty acid oxidation, the body immediately, conversely, decreases glucose oxidation by the exact same amount. So what happens is that first you're decreasing the glucose oxidation, and also what happens is that while you're oxidizing the fat, the body turns up the activity of the enzyme fatty acid synthase. So you're burning extra fat, but any food you ingest actually gets turned into more fat. It's not the glucose that you ingest. Part of it goes to lactic acid because Rendell cycle is blocking the oxidation of glucose while you're stuck in a fat oxidation mode. So they increase the fatty oxidation of these rodents with a drug that's used as a doping drug right now. It's called ICAR. I don't know if you're familiar with it. It's a nucleoside. It's spelled AICAR. Cyclists dope with it. Swimmers dope with it. I think Lance Armstrong was doping with it before he started doing the blood transfusions. It's a very popular drug for quote unquote endurance athletes. So what it does is basically it increases fatty acid oxidation, and it's thought that this is what improves performance. Anyways, this study showed that increasing fatty acid oxidation forcefully by giving this drug, and they increased the rate of fatty acid oxidation by 30 plus up to 40%. It led to absolutely no fat loss, no weight loss whatsoever. And if you look at some of the pictures, you'll see that the rodents that were basically part of the group that had increased fatty acid oxidation, they actually had increased weight. That basically it wasn't statistically significant, but they weighed more than the rodents that were in the control group. So they conclude that by saying that, first of all, they start by saying the fat mass is very well defended, rendering many lifestyle interventions ineffective. So that's what the study found, that if you try to trick your body by increasing fatty acid oxidation, so they did it with a drug, right? But other ways to do it is you either exercise more or you eat less, right? Because if you exercise more, after the first 10, 15 minutes, after all the glycogen is gone, guess what? You go into fat burning mode. Or another popular way currently is fasting or intermittent fasting. Basically, after your glycogen is depleted, when you're in a fasting mode, you're going to start burning fat. So what this study really shows, in my opinion, is that, at least the way I'm reading, is that they're saying, look, we have to come up with something else because increased fatty acid oxidation will not actually lead to weight loss. And what's more, towards the end, they say that fatty acid oxidation is actually really controversial. Some studies have shown that insulin sensitivity is decreased when fatty acid oxidation is being promoted. So long story short, they're kind of saying we have to pull the plug on telling people to increase fatty acid oxidation somehow, whether it's through diet, exercise, or getting these drugs that athletes do, because it doesn't have the desired effect. And we're not even talking about the health effects. They're just saying strictly about weight loss. This is not going to work.
Speaking of fasting, did you see somebody on the forum posted Peter Attia talking about how fasting turns down the thyroid? Did you happen to watch that?
No, but the forum lately has had some really weird posts. I don't know if you've seen them.
It has, but this one was actually pretty good because Peter Attia is often thought of as just a very high intellect in the longevity / low carb scene, and he I think he kind of made our point for us. Here it is. I don't know if I could actually play this. I don't know if people will hear it because I'm sure there's some track or it's kind of a few minutes, but it's pretty funny just because it's a huge low carb proponent talking about how fasting is devastating to the metabolism and it turns up the deiodonases that turn up reverse T3, and I guess he was talking about it because he does like extensive tests on himself, and he was talking about how reverse T3. I don't want to put words in his mouth, but I think on a few days later after fasting or something. Oh shoot, I should have watched it again before this. But he said his reverse T3 went to like 30, which is like very high when he was fasting. And then he was talking about being cold. And so again, this isn't anything new. Like anybody that's clued into their thyroid function knows that this will happen. But it was interesting because he's one of the people that promoted metformin as like an anti-aging drug. And so that's how kind of intertwined with this, in my opinion, nonsense view is. But
well, maybe somebody can send him the article on metformin cancer if he keeps taking it afterwards. But to anybody who has learned just a little bit of physiology, would immediately become obvious, considering that study about increased fatty acid oxidation damaging the liver. Most of the production of T3 in the body happens in the liver. That's where T4 is converting to T3. Anytime you inhibit liver function, which is what fatty acids do very, very well, as that study showed, right? Then you're going to have a buildup of T4. And that buildup, the body doesn't like a buildup of T4. And then it starts converting into reverse T3. That right there is a very simple and most likely explanation of why his reverse T3 showed up. But there are other things, as just as we discussed, like fasting starts breaking down muscle. All of these amino acids like tryptophan, cysteine, methionine that start flooding your bloodstream, they're all goitrogens. They're all anti-thyroid. They all suppress the thyroid of actually putting out even T4. So all fasting does, aside from the initial and minor benefit of reducing endotoxin in the first 24 to 48 hours, everything after that is really detrimental. There is just no way an environmental signal that things are not going well, which is what fasting is for any animal. There's no way that this can be healthy in the long run. I don't know of an organism that starves itself to health. I mean, I know animals that stop eating for a few days because they're injured, or they basically the food is really not is of bad quality. There's some reasons, but they never starve themselves on purpose and reverse sickness into health.
Can you talk a little bit about the obesity paradox? Because I apologize for anybody who's heard this before, but when I was in my band, we had like a really skinny guitarist, and one day I didn't know anything about nutrition at the time, or didn't really care, but he came into practice and was real sad. And we were like, dude, what's up? And he goes, I just came back from the doctor and I was diagnosed with fatty liver.
Yeah.
And he had like chronic health problems. Like he was a pretty depressed dude. I think he's worked it out now, but he was like a sour guy to be around a lot of the time. And he had acid reflux. So he had lots of obvious health problems. And that was like the first time I was like, wait, like my friend is so ridiculously skinny and like lean and like kind of ripped. I was like, how on earth could he have a fatty liver? It doesn't make any sense to me. And so just this topic reminds me of the things you had posted about. I don't remember all the details, but weren't the heavier people protected from like trauma and serious stresses?
It all started by basically these epidemiological studies which look just at associations of like all-cause mortality and BMI, which is like the simplest analysis you can do. And then they showed that the very obese, so basically the very obese and the morbidly obese, they had lower all-cause mortality than the people who were either skinny or all the way up to like the normal BMI. I mean, the healthiest people were in a BMI around 30, which is considered pre-obesity. But well, I shouldn't say the healthiest. The people with the lowest mortality were actually people who were mildly were like between overweight and obese. Like let's say overweight, based on BMI. Now, of course, BMI doesn't take into account muscle mass and fat, right? It just looks at weight per like a square per area of body surface. But that study was just was so controversial. I remember there were articles coming out that said like, even if this is true, this shouldn't be published. This should be relegated to like some kind of statistical oddity library, because like there's no way in hell this really is an actual fact of nature. Probably like the sample wasn't large enough, or it was biased. Anyways, scientist after scientist, these really important and famous people from Harvard and CDC and FDA, they got on the record condemning that study, saying that, first of all, it's probably wrong, right? But if it's not wrong, then why give the public more reason to gluttonize? Because of course the message is eat less and move more, right? But then like something strange happened. Like these new studies started coming out, and they actually looked at again BMI in specific diseases, and then they said that people who are again obese or morbidly obese, they had a dramatically lower chance of dying from cancer after being diagnosed with it. They also looked at these people, they said, okay, they also had much lower mortality from heart failure. They had basically a lower mortality from stroke, from ischemic stroke. And little by little, this thing started to accumulate, and now they're calling it the obesity paradox. So you can actually type it in Google, and you'll get a Wikipedia page, which lists, I mean, I think at this point it's more than 100 studies in all kinds of medical fields where this thing keeps coming up. It's like the people who are overweight or really obese for some diseases, they're doing much better than the skinny people. Actually, much better than the skinny people. Slightly less well than the people who are in the BMI between 30 and 32. But those people are still not healthy according to the medical definition. You're still overweight. If you're over 30, you're in basically the pre-obesity category, borderline obese. Well, long story short, I guess the explanation metabolically is that it's actually the person who can muster up the fat synthesis response from these excess electrons. They're the ones who actually, ironically, in a better health than the person who stays skinny regardless of the diet that they have. Now, of course, you can be skinny because you have high thyroid function, but that's very, very rare these days. More likely, you're hypothyroid to the point where even eating cannot really stimulate your metabolism to the point where even something basic such as fat synthesis can kick in.
So the electrons need an energy sink,
right?
And the new fat serves as that electron acceptor when the oxygen is impaired. And so, what if I understand correctly? You're saying that like a skinny person with impaired metabolism or mitochondrial respiration, they would be producing more lipid peroxidation or more ROS or oxidative stress.
Exactly.
Whereas the person putting on weight would actually be protected from this because they were synthesizing new fat fairly efficiently.
Right. So both people will be hypometabolic, but one person can actually deal with it like more optimally than like the fat people will be dealing more optimally with it than the skinny people, because all of these reactive oxygen species in this fat floating around, which is actually keeping them lean by damaging liver and causing a catabolic reaction, right? The free fatty acids, they're extremely catabolic. It was recently shown that the cause of cachexia in cancer and many other conditions, it's mostly due to excessive lipolysis. And blocking that excessive lipolysis, in other words, the free fatty acids, actually made these people start gaining weight. And most people with cancer, if they don't die from the chemotherapy or whatever treatment, they die from this wasting away, right? So anyway, so the bottom line is the people who are able to muster up this fat synthesis response are the ones whose metabolism was still well enough for them to actually do this, because that actually still requires energy, right? And the people who are even worse, they couldn't muster up this response, and then these excess electrons keep floating around. So they start attacking the polyunsaturated fats in your tissues, right? It's just the fact that there's free fat floating around. It suppresses the oxidation of glucose, fattens up the liver, just as your friend found out. So just because you're skinny doesn't mean your liver is skinny. And doctors are now starting to actually call it. I think the FDA came out with a new policy saying that every adult over 20 should be screened for NAFLD, which is non-alcoholic fatty liver disease, regardless of BMI. It's precisely because they saw that some of the worst cases of fatty liver disease are seen in actually very skinny people. So ideally, your thyroid is working well, and you are, in a BMI around 30. And if you can't do that, then it might as well be morbidly obese, because it's less it's less morbid and less lethal than being the really, really, really skinny person who actually cannot muster up that response of disposing off of these extra electrons.
And that leads us perfectly into the PUFA metabolites drive heart failure and possibly diabetes. And we're on heyda.me.com. Heyda.me if you want to follow along with what we're reading. So, George, you want to talk about this one?
Yeah, so basically they found out that there's this enzyme, actually a pair of enzymes in the body that metabolize PUFA. So when you ingest these polyunsaturated fats, one polyunsaturated fat, specifically omega-6 known as linoleic acid, gets converted into another one called arachidonic acid, still a polyunsaturated fat. And arachidonic acid can get fed into a number of different enzymes like COX or LOX. COX is cyclooxygenase and LOX is lipoxygenase. And then what comes out as a result of what these enzymes do to arachidonic acid is highly inflammatory mediators known as prostaglandins or leukotrienes.
But they're essential, Georgi.
Right, of course they're essential. That's he'll tell this to the people who are dying from heart failure or diabetes or Alzheimer's, which is another study that came out recently. So what the study found out is that basically a specific subset of the LOX enzyme, namely 12/15 LOX, is crucial for the development of heart failure. And then if you block it, then basically you eliminate the lethality from heart failure. And in many cases you can reverse it. It's kind of similar to that wiping out the microbiome. It's a similar, again, and we can talk how these are very similar because again, endotoxin, by the way, endotoxin is one of the strongest activators both of the COX and the LOX enzymes. Mm-hmm. So wiping out the microbiome may have this additional health effect of just decrease the overall inflammatory burden. Not only less serotonin, nitric oxide, but also less prostaglandins and less leukotrienes and less thromboxanes and less of many other downstream inflammatory mediators that are all synthesized from PUFA. So anyways, this study basically blocked this enzyme and found out that not only was heart failure, it became non-lethal, it was reversed in some cases, but also a few crucial biomarkers of diabetes too were also completely obliterated. I think one of them was adipic acid is what they call it. So even though they don't, 2-amino adipic acid. So this is actually one, and it's currently being considered to be officially approved as a biomarker for diabetes type 2. Currently, the way it's diagnosed, diabetes, you go to your doctor, they do a fasting blood glucose test. If it's over 120, then they'll send you to do a glucose challenge test, right, where they give you like a bolus, they give you a glass of 70 grams of glucose. Sometimes they even do it intravenously. But you chug it, and then they measure basically your insulin response and how quickly your blood glucose declines after that massive amount of sugar, and then depending on that, then you can either get officially diagnosed with diabetes or not. Anyways, long story short, that's not a very reliable test because just as we know in so-called gestational diabetes, it really isn't diabetes at all. It's something that's temporary and actually has been shown to be beneficial for the mother and the pregnant child. The pregnant mother and the child. So a much more specific and sensitive biomarker apparently is the levels of this metabolite called 2-amino adipic acid, and studies have also shown is that if you lower this metabolite, you're actually starting to reverse the pathology of the diabetes type 2 as well. Mm. Well, guess what? Inhibiting 12/15 LOX did that as well. So by conversely, you can basically say is that, well, why bother inhibiting a downstream enzyme when really, so this enzyme cannot do much damage if it doesn't have the raw material. What's the raw material for the inflammatory mediators? It's arachidonic acid. What's arachidonic acid? Where is it coming from? Well, the PUFA in your diet. So once again, restricting PUFA may actually have this profound beneficial effect on two. Well, one of them is lethal condition. The other one may be lethal, right? But still, these are health epidemics at this point. Diabetes type 2 was recently classified by the United Nations as the #1 health crisis in the world. It may be treatable as simply as just not eating the seed oils, How about that?
I am forgetting the names, but I tend to think about the lipid peroxidation and the prostaglandins. I know the leukotrienes and things, but Ray had a bunch of other toxic byproducts, and so you're reminding me that there's a constellation of bad byproducts that I never really think about involved with the metabolism of arachidonic acid, but.
Yeah, it's the malondialdehyde, which is the lipid peroxidation byproduct that happens when you have the attack of the unsaturated lipids by the reactive oxygen species. Mm-hmm. There's a test called T-bars, which I think is thiobarbituric reactive species or something. These are all product of lipid peroxidation of the non-metabolic degradation of the of any unsaturated fat, really, whether they're omega-3 or omega-6. So all of these. So instead of chasing these enzymes, and that we probably don't even know all of them at this point. I mean, new enzymes are being discovered every day that metabolize these evil fatty acids. How about just restrict them in your diet? We're really not meant to thrive on those.
Okay, unless there's anything else you want to say, we could traverse into questions.
I wanted to cover the one on niacinamide that may prevent vascular calcification.
My bad. Let me switch back over here.
And the tetracyclines, of course. Yes.
Say it again. Which was the name?
Niacinamide tetracyclines may prevent reverse vascular calcification.
Oh, here we go.
So that's a great study because it ties in with the energetic process so well. So it turns out there's this enzyme in the body. It's called PARP, poly-ADP ribose polymerase. And that enzyme consumes NAD, basically depletes you of NAD. And in the process, of course, it lowers the NAD to the NADH ratio. In other words, it puts you in a more reduced state. And the purpose of this enzyme, the main purpose is actually DNA repair. So anytime there's DNA damage, whether it's from radiation or some kind of a toxin that's known to be genotoxic, anytime there's like a DNA strand break in damage in general, this enzyme is called into action, and it uses NAD to basically perform DNA repair. So it sounds like such a good enzyme, but guess what? It's highly overexpressed in cancer cells, which is not surprising because they have a lot of DNA damage, right? And they want to repair themselves. But in the process of depleting NAD and thus lowering the NAD to the NADH ratio, as we know, this is such a systemic biomarker and also regulator of metabolism. Anytime this ratio gets lowered, you basically block the oxidation of glucose. You increase the oxidation of fat. You increase the synthesis of fatty acids because you have, again, buildup of electrons, right? You've depleted the oxidized version, and which is the NAD, and you have a relative buildup of the NADH. So it's been shown that the lowering the NAD to the NADH ratio is really not good, right? So many drugs have been designed to inhibit PARP, the poly-ADP ribose. I'm going to call it PARP going forward. And in fact, there is one drug which is currently a blockbuster cancer drug, and I think it's approved currently for breast cancer and ovarian, but they're trying to approve it for every type of cancer, and it does nothing except inhibit PARP. Mm-hmm. Well, apparently, PARP overexpression, PARP overactivity is somehow intimately involved in the process of taking calcium from your bones and basically depositing it into your arteries, which is what cardiovascular disease really is all about. Mm-hmm. This plaque that is on your blood, that is lining up your vessels, it basically consists of calcium, fat, and some inflammatory, like basically some cytokines and white blood cells. So anyways, the PARP enzyme apparently is involved in this process of calcification, and blocking PARP completely prevented it and reversed it. Now, this specific study used minocycline, the antibiotic minocycline. It is a member of the tetracycline family, and they say in the study that, in their opinion, any member of the tetracycline family would work. They just happen to use minocycline. But guess what? You don't need to use an antibiotic. The clinical standard to this day for inhibiting PARP is actually niacinamide. So you you can type PARP niacinamide PARP inhibitor, and you'll get an entire Wikipedia page which talks about how, first of all, niacinamide raises the amount of NAD in the body, right? Mm-hmm. But also in higher doses, it specifically inhibits PARP. And now studies are trying to get higher doses niacinamide approved for the treatments of things like rheumatoid arthritis, multiple sclerosis, lupus. In other words, all of these autoimmune conditions that really little by little are turning out to be just the same disease manifesting differently. And now it seems like it's also responsible for vascular calcification. And as I explained, overexpressed PARP is apparently apparently involved in cancer. So it all comes down to energetic bioavailability and the ability to produce energy from food, and NAD to the NADH ratio is very important, and niacinamide kills two birds with one stone. It raises that ratio and inhibits PARP directly.
Sweet. Well, were there any other ones?
I think that's pretty much it, except if you want to talk about the playfulness and novelty and
I
the
do want to talk
humility.
about that one, yeah.
Yeah, it's the kind of like the more of the social aspect of because it still ties up with energy, but I think people like those because it shows them how the ability to produce energy affects every aspect of life. It's not just your when people think of health, they think like, oh, blood glucose or like my liver or my pancreas or my bones. No, your brain really it starts with your brain. 40% of the calories you consume, they go towards supporting your brain. So everything you are is consciously you are. It actually, it depends on the brain and its function. So the first study, which I really like, is that show that people with more intellectual humility have superior general knowledge. Now they said general, but if you look at the study, they didn't really say general. They basically tested a bunch of people on different measures of cognitive function and and knowledge, and they found that people with more intellectual humility score better across the board. So how about saying people with more intellectual humility are really more intellectual or smarter or whatever you want to call it? And why? How does this tie into energy? First of all, what's intellectual humility? They used, I like that word because it does tie very well with Ray's writings and writings of many other people before him. All the really smart people in this world were really very, very humble. They realized how little they know, and they just kept learning their whole lives. So intellectual humility is a good word here, but if you read the actual study, they're using it as a euphemism, as a replacement for open-mindedness. And we've talked about open-mindedness, how it depends on energy production, right? People who have an excess of energy, they can afford to take in new information. They can afford to expand their knowledge. People who don't have the energy, they view the world as a threat. Everything that comes in as new information is a threat to their state of life, is a threat to their life, really. So it's very common you see people in a very authoritarian, very high authority positions. They're really it's hard to talk to them because they think they know it all. They're just there to give orders, and it's just a sign, a symptom of really deranged metabolism. Because a person who thinks they know it all, well, what are they doing that in this earth, right? They have no reason to live if they have figured it all out. And it's been shown that children are, on the other hand, knowing that they have a much faster metabolism. Children are very intellectually humble, and children are very open-minded. To them, everything is a game, everything is a learning process, which leads us to the playfulness, which we'll talk about later. Everything is an opportunity to grow and use this information to enhance, to enrich their existence. They don't argue. If they argue, it's because you took their toy. But they're not going to, if you tell them that, cancer is caused by genetics, they're not going to argue. They'll probably just sit there with the thumb in their mouth, and they'll listen, and they'll listen some more. But that's what they do, and they can afford to do it because they have the sufficient energy to process all of this new information. And that study showed that people with less intellectual humility, they thought they knew more, but they actually knew a lot less. And this reminds me, I put the link in the article if you saw, about the Dunning-Kruger effect. Most people, I don't know if they've heard of it, but basically the gist of it is that dumb people are really sure of their abilities, and smart people are really full of doubt. So,
yeah, it's like the most confidence is associated with the least amount of intelligence, and then as you go down, you gain more intelligence about a subject, your confidence decreases.
Exactly.
So I think the Dunning-Kruger effect is sometimes used in pop culture to say somebody's stupid, but that's not really what it's means.
Yeah, that's right. It just shows that a smart person will realize that any area of knowledge is an open system, and there's no end to it. It's an infinite system. So you'll keep learning and learning and learning, and there's no end to it. While the more stupid person will be like, oh, I learned everything there is to know about this, so now I'm going to go and control people and tell them how to live their lives because I know better and they know less.
I think Karen might have said this, but in one of my podcasts with her, but she said when you're sick or you're low energy, you want these finite conclusions. That's what you crave. Closure isn't the right word, but consensus.
Well, you don't have to spend more energy on them, right? Yeah. It's almost like a mathematical proof. I proved it once and for all, and nothing in this universe will ever change the result, right? but that's not how the real world works. It's always changing.
But like I think she said this too. But when you're like when you're healthier or you get healthy or whatever, like the last thing you want is some like perfect thing with a bow tied on it. You know that there are infinite possibilities and different ways to look at the same thing. And again, not to put you on the spot or anything, when I talk to you, like I feel like you exude that. And it's one of the things I really appreciate about you. And I think Ray exudes it as well as Jawhead. I haven't talked to Steph as much, but the communication with her is always like extremely in a similar vein. You know, like intelligent people, I don't think try to impose themselves on other people. And I think they're, even if they were to come up against an idea that was out of the ballpark or something, like, I don't think the immediate action is to like shut it down. There might be some element of that that could be useful. And I have examples of this, but I actually don't want to say them because I think our like stream could be taken down because of the YouTube's so crazy now. So, but yeah, I really appreciate that you posted this. I actually brought up Ray's quote in Nutrition for Women. And he says, once we accept that knowledge is tentative and that we are probably going to improve our knowledge in important ways when we learn more about the world, we are less likely to reject new information that conflicts with our present ideas. The attitude of expecting will allow us to apply insights gained at one level of generality to other levels. No particular kind of knowledge will have such an authority that it will automatically exclude certain possibilities in another field of knowledge.
Right. I really like that quote. But back to the children here that we discussed. So if children are the epitome of basically if they're people with the most intellectual humility, and also they also have the most knowledge, what else do children do? I mean, what else if not play, right? That's like the one fundamental defining characteristic of every healthy child. And it's not a coincidence when I say healthy, because one of the first symptoms that a pediatrician looks for in a child is, did the child stop playing? Is the child playful? Does it enjoy life? Does it enjoy what it used to do, right? And so playfulness, then you may make the connection that when maybe playfulness and intelligence, playfulness and intellectual humility, maybe they're related, right? And it turns out they are, or at least when it comes to survival. So the article I want to talk about is that basically it's more of a really like an editorial, but basically it showed and discussed different cases in the animal world and in the human world, where basically it showed that what we call playfulness, what we call play, is really actually a very serious activity. It's the ability of the organism to look at its environment in an unstructured way. Nobody's telling this organism what to do. Nobody's ordering them around. Nobody's telling them this is right and this is wrong. Just let them be, and they will figure it out. And just all this article does is really goes through like a number of different examples from the animal world, showing that especially like the youngsters of the animals, they basically had much higher chance of survival in the wild if they were allowed to play. Like whenever they were bred into captivity and then released, they basically the studies found out that the reason domesticated animals that were then released into the wild didn't do so well wasn't because they were somehow they lost their instincts, right, or their brains were damaged, or they learned to associate with people too much. It was because they were put in a cage and their life was too structured. They weren't allowed to play. Mm-hmm. When you allow organisms to play, it's a very crucial part of survival, but more importantly, turns out to be a very crucial part of discovery, of creativity, and of progress in science. So there are multiple examples given by various scientists how basically they came up with their discoveries not while working on them in a lab, but when they were taking a break. They went for a walk, they took a vacation, they changed their environment, and they were in a situation where they were more or less free to do what they want, to do what they want with their time and with their lives, and nobody was ordering them around. Which, sadly, if most people probably are now thinking, wow, that sounds exactly the opposite of my life right now. Well, that's what society, that's really how society has degraded to that point, that we have very little of that time to play, to experiment, and to enjoy ourselves without being told what pleasure should be, right? protected sex? No, it's such a bad word for. It's like as if you need protection from one of the very vital activities in life. I'm waiting for protected food or some other idiotic misnomer that they'll come up with. But anyway, it's a really good article. The gist of it is play is really not to be played with. There's nothing funny. There's nothing silly about it. It is a vital part of life, and without it, there can be no progress. So true knowledge will not come out of the lab. True knowledge usually comes out by preparing in a lab and then unleashing your mind to just go out there and experience in the world.
Sweet. Okay, so just before we get into questions, just a reminder that we are giving away another bottle of ID Labs Tocovit vitamin E. And so to enter, just subscribe to the channel, like the video, or the live stream rather, and then leave a comment. And just so this is more for people watching after the fact. So thanks, guys. We have like a record of amount of people in here. So thank you guys so much. Super fun to do this. Thank you to Georgi for making this an excellent Friday night.
My second bottle of tea.
And Georgi is just running through the tea tonight. That's what you guys are doing to him.
It's like basically there's 70 grams of sugar in every bottle. So like I've done 70 so far. I have another 70 to go.
Awesome, guys. Okay, let me change.
By the way, I've measured my blood sugar after these massive boluses of sugar.
Yeah.
And after about a half an hour, my blood sugar is lower than when I started.
Really?
Yeah, my doctor is like is shocked. He just mumbling incredulity. He's like, "Ha, you're taking something. This cannot be happening." Like, yeah, dude, it's called niacinamide. Have you tried it? He's like, yes, it's vitamin B3. It shouldn't work like that.
Okay, we have a serious amount of questions, so I just want to mentally prepare you for this. So we probably should focus on brevity because I think we have like 38 questions or something. So, and some of them are kind of long. So we'll try to get through them in a timely manner, and then I'm sure we'll probably have super chats at some point. Okay, number one, Ellie, who is a great person, asks, can methylene blue be safely consumed throughout the day at around 8 milligrams dissolved in water, baking soda, and sugar?
My answer is yes. I think the human studies which found absolutely no side effects used up to 50 milligrams daily in people with severe mental illness, and not only it reversed bipolar disorder and severe suicidal depression, but it had, I remember the study said, virtually no side effects except minor indigestion in only 2 people out of I think 70, and those people had gastritis. So more or less 8 milligrams is half of that. The only thing I would try to do is not combine it with things like that contain tyramine. So in other words, aged cheeses, chocolate, some wines, because tyramine is also, I think it's a monoamine oxidase inhibitor. So is methylene blue. It shouldn't cause problems in these dosages that low, but just to be on the safe side, just make sure you consume it a few hours before or after foods like that.
And then Ellie also says, is unwanted hair growth in all sorts of unwanted areas a sign of things going wrong? What can be done to remedy that, be it topical or systemic?
Yeah, hair growth in general is a sign, especially if it's like in ears, nose, neck, and things and places like that. It's usually a sign of elevated cortisol, or at the very least, an elevated ratio of cortisol to progesterone in women, or cortisol to DHA, cortisol to testosterone in men. Many people associate hair growth with the androgens, but it's actually cortisol activates the peripheral synthesis of androgens, which you don't want, and the skin is one of the largest steroid synthesizing organs. So if you're getting that, suggests adrenal overactivity at the expense of the gonadal activity, which in women is the synthesis of progesterone. So I would say if progesterone would be the first thing I would try, because it also happens to block cortisol directly.
Just a quick story about this. One of my trips to Japan, which was basically like 2 days of not sleeping and just being in hell, I remember getting to my Airbnb and noticing like a long dark hair just like growing out of the side of my ear. And yeah. So I think we had talked about this in some capacity, and I was like, oh yeah, that's definitely probably cortisol or estrogen or something, because That was like 2 days of hell. Okay, Yale says, planning on trying to eat very low fat for a few weeks to achieve faster PUFA depletion. Since niacinamide prevents the breakdown of fat, could it slow down the PUFA depletion? And would it be better to stop taking it for those few weeks?
In the doses, go ahead. If you have any
he said he's taking 1,000 or 2,000 milligrams a day to support his kidneys. Thank you, he says.
So why such a high dose? Would be my first question. Is usually such dosages are used in people with chronic kidney disease to lower excess phosphate and prevent further kidney damage. Unless there is kidney damage already present, I wouldn't take more than 500 milligrams, and I think most people know Ray recommends no more than 300. So niacinamide really in the lower dosage only blocks excessive lipolysis. There is always some baseline lipolysis because your muscles at rest burn mostly fat. So I don't think that niacinamide in the dosages of sub 500 milligrams, I don't think it can block the lipolysis to the point you'll be interfering with the loss of fat. But just as a reminder to the study that we just discussed, you don't want increased lipolysis to the point of basically going to fatty acid oxidation mode, because you will not lose weight, just as what the study showed. You're probably going to cause more damage. What you need to do is block the excessive lipolysis, and then whatever extra fat is there, if the liver is healthy, over time it will glucuronidate that fat, and you'll come out as part of your urine. So that's the healthy way to dispose of the extra fat. Keeping metabolism high, making sure muscle mass is optimal, right? So a little bit of weight training, making sure the steroid balance is optimal. Thyroid is very important as well. Building muscle mass, keeping liver healthy, and that over time should get rid of the excess weight. You don't want to be playing with inhibiting lipolysis too much by taking these massive doses of niacinamide, because in higher dosages, it does have side effects. Liver enzymes have been found to be elevated with dosages of 3 grams or more daily. I think in the very high dosage, it starts to actually block beta oxidation directly, which can lead to accumulation of ammonia. This only happens in really high doses, like 3, 4, 5 grams daily. But again, if there's no reason to take 1 or 2 grams, I would drop down to 500. And no, it will not prevent you from losing weight. It will only block the excess lipolysis, which actually damages organs. If you want to lose weight, focus on raising metabolism, increasing muscle mass, and keeping the catabolic hormones in check.
Sweet. Do you want to turn that on, or it doesn't matter to me, but up to you.
Oh yeah, the light. Yeah, just a second.
Guys, thank you so much. Thank you to the moderators. Thank you to everybody hanging out with us. Sincere from the bottom of my heart. Thank you guys so much. I feel like I finally kind of got a hold of this. It's pretty complicated. So this time has been less stressful than the other times. So knock on wood, hopefully nothing goes wrong. But thank you guys again. Super, super excited to continue to do these and to have an audience. And of course, thanks to Georgi and the mods and everybody make it special. Okay. Baria says, do you have tips to deal with frequent urination?
Yeah, usually it comes down to having actually not enough salt and too much liquid, too much fluid in your body. And the way the body raises metabolism is by making you pee out that extra fluid, and it increases blood volume, and that has a temporary metabolic boosting effect. But really the underlying issue is too high adrenaline and low thyroid. So sometimes just eating slightly increasing protein intake and salt sometimes tends to lower the adrenaline. If that doesn't help, then I would consider thyroid, because ultimately it comes down to too high stress hormones and too low thyroid.
I was going to say, I couldn't even make it through a movie without having to go pee when I wasn't taking Sinoplus. And then that's one of the symptoms that I really closely link with my thyroid function. And I don't even think I could talk to you for a few hours if I wasn't taking the Sinoplus. It's like one of those things. James Bevan says, I'm taking antibiotics for a sinus infection, and I'm noticing some fungal infection signs, which often happens. As a matter of course, I know a lot of people recommend antifungals alongside antibiotic courses. Could you let me know which antifungals you feel are the safest and most effective including dosage and frequency. Thank you for your insightful work.
Actually, the ones that are prescribed pharmaceutically, the ketoconazole and I think the miconazole, they all have side effects. Actually, the ketoconazole is it inhibits several enzymes in the steroidogenic pathway, and now they're considering using as a drug for Cushing syndrome and for prostate cancer because it inhibits the theories that the androgens cause prostate cancer. So now they're going to use this antifungal as a steroid inhibitor. So they all have side effects. So it really depends on how severe the fungal infection is. But there's some dietary measures that can help depending on how severe the fungal infection is. Aspirin is a potent antifungal. Niacinamide is a potent antifungal. Methylene blue is a very well-known one, and that's why they use it to sterilize the fish tanks because they usually have an overgrowth of fungus. And then I think baking soda also tends to have an antifungal effect. So I would try these before jumping on the pharmaceutical antifungals. Their side effects are not pleasant.
Okay. I would be interested to know what the side effects he's associating with the fungal, because I'm not saying this is, I believe that is a problem, and I do have papers about that, but I don't think I've ever, and again, I could just be not noticing it, but I don't think I've ever noticed a fungal infection after using antibiotics. But again,
he may be thrush. He may be seeing thrush on the tongue, and that may be a local thing. But it is common, actually. It is common to prescribe because doctors believe that if you kill the bacteria, then some opportunistic fungal infection like Candida will get out of control. I don't think that's true. I mean, I know people who've been taking antibiotics heavily for something like Lyme disease, right? They take 400 milligrams of doxycycline for 6 months. So that completely wipes out their microbiome, and none of them have developed fungal issues. But that's what medicine does. I mean, it's a standard therapy.
Sweet. This another one from James. He says, I'm running a zero starch diet at the moment for the first time ever, and I'm frustratingly making me feel markedly better in terms of mood and digestion. I'm assuming this may be an endotoxin issue. I really want to introduce starch again because well-cooked potatoes with butter are so good. They are like religion to me. Do you have any tips and suggestions to help me reintroduce starch, perhaps food supplements to have alongside?
I don't have a problem with well-cooked potatoes as long as they're well-cooked and they're turned into mashed potatoes and there isn't any much uncooked starch. Potatoes are good. They have keto acids, right? They're going to help you build protein without the extra ammonia that comes with dietary protein. So if starch made you feel good, I don't see a problem not using it at all. I mean, I would still try to restrict it as, see if, how you do on one meal or maybe 2 meals. But if you eat starch, make sure it's always the easily processable starch, not the resistant starches that, make it to your colon and feed the bacteria there. So well-cooked white rice, mashed potatoes, well-cooked potatoes, whatever, how you want to eat them, and maybe lentils, well-cooked lentils. That's as much as I would go starch-wise.
Yeah, there's such a weird, or to me a little strange, thoughts about starch. I was never I have a hypothesis that maybe the people that feel really good eating starch, maybe they're getting a lot of salt on the starch, possibly, I don't know. But once the mushrooms, I was able to incorporate the mushrooms in my regular nutrition. I really felt like I had, it was way more annoying to be chronically cooking potatoes. And then the digestive aspect, for me at least, was he's asking how to reintroduce them to make them work. But I think for some people, they just don't work.
But I thought he said that for him starch worked, but zero starch didn't. Is that what he was saying or not?
I think the opposite. That's how I heard the question. I know it's kind of confusing because it's a longer question, but he's saying, I'm running a zero starch diet at the moment for the first time ever, and it's frustratingly making me feel really good. And
so why is it frustrating then?
That's James, your question is a little bit confusing.
Yeah. So look, I mean, this is my sugar. Today I've eaten zero starch, and I've never craved it. I do crave sweets, but I don't crave starch. And if zero starch is making you feel good, then I wouldn't be worried about it. That's how it's supposed to make you feel good because it's less endotoxin.
Yeah. Yeah, and again, I talked to someone. Somebody emailed me a long time ago, and they said their son had like chronic endotoxemia, and she told me, I really think Ray is onto something because she knew for a fact that her son could not tolerate like any starches. I think he was autistic, and so that meant a lot to me because here's this person like totally outside of the nutrition sphere, doesn't have anything to. She's just going by what works, you know. And so that always made an impression on me. Tommy said, we're cruising through these questions. Tommy says, is it true that if I eat a low fat diet, less than 20 grams of fat per day, body releases a lot of PUFA from the tissue to float around, or does it happen only during a caloric deficit?
I think it only happens during caloric deficit. So the amount of PUFA that's released in your bloodstream, you're only going to get more fat released if you somehow get into a point where your muscles are like starving energetically, or you get fat released when you're under stress. Strong stress could be caloric restriction. Other stress could be adrenaline/cortisol. So if you're overexerting yourself, if you're under stress, whatever that stress is. So if you're lowering the amount of fat in your diet and then the remaining part of your diet is carbs, you won't be releasing, compensatory fatty acids, because while you're eating the carbs, lipolysis is inhibited. I don't know of a way the body can circumvent that mechanism. The only people that I've seen that happen have a very rare condition called pheochromocytoma. It is an adrenaline-producing tumor, and in those 1 in a million cases, the sugar actually cannot block lipolysis because they have a tumor that produces adrenaline, and it's really the tumor causing the excessive lipolysis. So that's not a concern for most people. So while you're eating the sugar, I don't think the body will be able to adaptively release more fat because it wants to.
I lost consciousness for a second, but you were saying earlier that how when a person eats a low-fat diet and they're eating lots of carbohydrate, the liver is the glucuronidation is one of the primary ways that the PUFA
right. But I think he's asking that if he eats below a certain level of fat, wouldn't the body release more fat to somehow compensate for it?
Okay, I misunderstood.
And I don't think this will happen for two reasons. Number one, if you're eating carbs, the insulin response from the carbs and the carbs themselves greatly limit lipolysis, right? While you're eating the carbs and while you're processing them.
Yeah.
And number two, I don't think there's a mechanism through which the body has to meet certain amount of like fat in the bloodstream.
Yeah.
There's no requirement for fat in the bloodstream, and if your muscles are getting other nutrients, they're not going to need that fat.
Sweet. Okay. James Brown says, I've always gravitated towards being a night owl. Is this linked to higher cortisol? Definitely. I suspect it's hurting my morning temperatures, which are always low. What do you think?
I think it's linked to either higher cortisol or at the very least the so-called inverted pattern. So typically what needs to happen is your cortisol needs to get into a pattern where basically it's high in the morning, then it starts to decline, should be lowest at around 3 to 4 p.m., and it starts to rise again, as soon as the sun starts to set and you get into the darkness. So the night owls have been shown to have the reverse pattern. Basically, they're very low in the morning, and then they slowly start to go up, and their highest cortisol is between 9 p.m. and 11 p.m. And then it starts to decline, but it doesn't decline until like 3 or 4. That's why they typically stay so late. And then they fall asleep. And because their cortisol is lowest in the morning, these people tend to sleep until noon because cortisol it's inverted pattern. If you have an actual high cortisol where it never goes down, it's not inverted pattern but simply elevated, then you'll probably be feeling jittery all the time because that cortisol will prevent you from even doing the regular sleep that you do as a night owl, which is like from, let's say, 4 a.m. to noon. So if cortisol is always high, you'll actually have problems sleeping no matter when you try to sleep.
Yeah, two things I would add to this, because I felt like James, the tendency to be a night owl since I was like a little kid. And so the one thing that I've noticed for myself that really can like switch that circadian clock is vitamin D. And so if I'm low, I'll tend to be up all night and then be really tired in the morning or sleep like way too late. And so vitamin D seems to be that. And then I went on a tear one time, and people with liver problems have like hypersomnolence too, and they tend to have insomnia in the nighttime and sleep all day, and that could of course be connected to the vitamin D too. So
DHA is another thing that was shown to reset the circadian clock.
yeah,
You can try that too.
I remember we posted that.
Yeah.
Sweet. Thank you, James. Julia says, thoughts on exposure to dental mercury and approach to support detoxification of heavy metals in general?
I don't think that any dentist at this point uses the mercury amalgams unless you're like in a really third world country, and but even those countries are now starting to use polymers. I mean, mercury has been at this point labeled by so many health authorities worldwide as such a dangerous carcinogen and toxin that I don't think is present in anything medical that is these days being used to be put into us to stay chronically. But if you still have the amalgams, basically it's been shown that as long as you keep metabolism high, the little bit of leaching that happens from mercury is really not that dangerous. Things that help chelate mercury, aspirin is one thing. Vitamin B1 was shown to also help chelate. Niacinamide was shown to prevent the kidney damage that mercury is known to cause. In general, heavy metal detoxification, basically most of the organic acids, amino acids, like the acids like malic acid, citric acid found in orange juice and apple juice, sugar, especially the fructose component, these are all known to chelate metals, especially with a preference towards aluminum, nickel, and cadmium. I think alpha lipoic acid is used for chelating lead, but Ray has spoken against it simply, and he said that, well, it is going to take it out of your brain and your spine, but you don't know where it will be deposited. And he said that if lipoic acid is used, then he said it should always be used with thyroid, just so that the thyroid makes sure that whatever is getting chelated is actually getting glucurinated and excreted, versus being redeposited somewhere else, like your brain maybe, or your liver or your spleen.
Yeah. There was a guy named Andy Cutler who wrote a book on mercury chelation, and I had tested high levels of mercury and lead, and his protocol was basically to take lipoic acid and also DMSA, and
Right.
his whole idea was like you should choose like 2 or 3 days and then take them continuously, like every 3 hours. And I can't blame it specifically on that approach, because I was like flirting with low carb at this same time. But during the end of that like chelation thing, like after a year, I was probably like the sickest I'd ever been. And I only much later remember listening to Ray saying exactly what you said, that it's dangerous to mobilize these metals and they might just be sitting around inert, and you don't want to like activate them. And then speaking to Ray's just amazing simplicity of him talking about coffee and orange juice and milk, like having a chelation effect, I was like, oh man, this guy is just awesome,
Yeah, it's some of the organic acids, the lactoferrin, since it has affinity for iron, actually has affinity for many other metals. That's why milk chelates. And the orange juice, to my knowledge, is because of the citric acid. It has a little bit of malic acid as well. Succinic acid actually is a great metal chelator, I forgot to mention. It was used in the early 20th century by many, but it wasn't only Otto Warburg and Linus Pauling working with it. They basically were found out that it chelates a great number of metals, but you have to use it judiciously, because it can chelate things like copper and iron as well. So you don't want to chelate copper too much. It's such a crucial part of the respiratory enzyme cytochrome C oxidase. So yeah, maybe best is just to leave it alone. If you do chelate, make sure you take thyroid, because really it's the high metabolism that prevents most of these metals from doing any damage.
Julie has another question. She says, does vitamin K2 MK7 have any value? From what I've read, it's the only K2 supplement that is sourced from food compared to supplemental MK4, which is synthetic.
No, actually MK4, from what I understand, it's most so some people synthesize it, but the cheapest way to get it is to extract it from tobacco. Mm-hmm. So MK4, when it's industrially produced, most often comes from a plant extract. And so MK7 does have some vitamin K activity, but keep in mind that the primary endogenous vitamin K isomer is MK4. So most of the dietary one comes as K1, which is phyloquinone, and it's present into these leafy green vegetables. but it doesn't by itself. Actually, by itself, it only has a hemostatic effect. The respiratory effect, where it can serve as a replacement for coenzyme Q10, it only and basically the effect where it carboxylases osteocalcin, this protein that's responsible for taking the calcium and putting it into your bones. All of these functions are performed only by MK4. So MK4 is the primary endogenous vitamin K form that we use. When we take K1, we can only use it for blood clotting, and any other function requires conversion into MK4 by the intestinal bacteria. MK7 came out mostly as out of research from the soy industry in Japan and the cheese industry in the Netherlands. If you check the original studies, they were all sponsored by these industries. So I'm always a little bit wary of research like that, as it does seem like it should have an effect similar to MK4. But if you're going with what really is the endogenous form, it is MK4, and MK4 is mostly extracted from plants. The synthetic one is very expensive. You're paying thousands of dollars per milligram, and for that reason, they mostly use it as an analytical standard when they need to compare, we need to find presence of vitamin K in some kind of a sample. They use in the synthetic one because it's so pure to do the mass spectroscopy analysis and HPLC analysis.
Sweet. This one's from Dodie Sharp. She says, in a recent email exchange with Dr. Pete, he stated that nitric oxide is the driving force when skin is hot to the touch, yet core temperature is below 98 degrees Fahrenheit. My husband is and always has had enough heat emanating from his skin that I could feel it standing 6 feet away from him. His TSH runs about 4.6. On the other hand, my temp is around 98.2 to 98.6, and my skin is always cool to the touch, even when my hands and feet are warm. We both take thyroid meds, but in different forms. He has zero body fat due to a leukemia diagnosis. Can you elaborate on nitric oxide's actions when a person is emaciated? How can it still be acting so forcefully in such a condition? Thank you.
Well, nitric oxide actually promotes lipolysis, and just as I explained earlier, the cachexia in cancer is mostly driven by excessive lipolysis and inflammation. So also nitric oxide activates the synthesis of serotonin, and I think, I don't know if this is a disagreement with Dr. Pete or it's a corroboration of his statement, is I know that people, so one of the diagnoses for serotonin syndrome is precisely the surface temperature. So people with excess serotonin have the exact same symptoms. And because serotonin and nitric oxide, they always go together. Mm-hmm. So I'm inclined to say that serotonin is also involved, or maybe nitric oxide is actually driving serotonin production, and serotonin is the actual cause, or the other way around. But one way or another, I think serotonin is also involved, because as soon as they give people in the hospital with serotonin syndrome cyproheptadine, their surface temperature drops, but their core temperature increases, which is a sign of improved metabolism. And usually in these states, when you have high lipolysis, which is driven by adrenaline, you get the exact same thing. You have surface temperature is high, but core temperature is low. So that will be my explanation. In terms of resolving it, I will try the cyproheptadine. I think Benadryl has some of these anti-serotonin, anti-nitric oxide effects. So that's something else that you could try that's over the counter. And if lipolysis is truly involved, then aspirin and niacinamide should be able to bring it under control pretty quickly. And they both happen, by the way, to have anti-nitric oxide effect.
Thank you, Georgi. Thank you, Dodie, for the question. Baria says, any tips on benign prolapsed hemorrhoids? I have noticed skin enlargements in the area, not painful, but there is occasional bleeding with large feces passing. Any vitamin topicals that could help?
So usually the hemorrhoids, and in general, enlarged or varicose veins on the lower extremities, usually driven by enlarged colon and or increased endotoxin. I know people who took antibiotics for different reasons, mm-hmm. and they had huge hemorrhoids retract back inside, and they never came back. Mm-hmm. I also know people who had theirs, they keep theirs basically, inside of the rectum, and preventing them from prolapsing by taking methylene blue. So nitric oxide is probably also involved in this, but in general, it stems from a digestive / colonic dysfunction. And anything that you can do to improve speed of transit, basically not allow fecal matter to build up, should help. And because the slowing down of digestion in the colonic area is usually due to increased serotonin in the colon, I also know people who have had good results with cyproheptadine and ondansetron. So those are some of the things I would try. I wouldn't necessarily try to do anything as a suppository yet, because it may cause even bigger irritation in that area, and you don't want to aggravate it even more.
Thank you for that. How you doing, Georgie?
Fine, man.
Okay, good. We're like a third of the way done. People really gave us the questions on this episode. Okay. Thank you guys so much for listening. Appreciate it. Chat is still going, as I see. Okay, we'll keep going. Chuck Soul says, is hunger a reliable indication of nutritional need, or could this be a symptom of poor glucose oxidation / low thyroid? I find that an insatiable appetite often coincides with unavoidable weight gain. Is it possible to ignore hunger without adding to the cycle of stress?
I think hunger is a great sign, and in fact, most people who waste glucose, they actually have poor appetite. Diabetics are not very hungry, whether they're type 2 diabetes or type 1 diabetes. Usually, hunger means blood glucose has dropped, and most people with like a blood sugar problem, hypothyroid condition, they would have actually, like slightly elevated blood glucose because of the high cortisol. So I would go by what you feel, and if you're hungry, I would eat. Usually, weight gain does not manifest if you're restricting the fat. It's if your fat intake is less than 50% daily based on calories, there shouldn't be much, if any, weight gain. If most of your calories are in the form of protein and sugar, there shouldn't be much of a weight gain. I think hunger is a great sign. It used to be one of the core symptoms of recovery in the sanatoriums that they had after the World War I and World War II. All these people that are coming from the front lines and being stuck in those sanatoriums for months, sometimes years. One of the requirements for discharge was, did the person start to ask for food on a regular basis? So it is a great sign of recovery. It's a good sign of health.
Chuck has another question. He goes, if greater lean muscle raises the basal metabolic rate, what would be a thyroid-friendly weight lift and recovery protocol to achieve this while keeping cortisol, etc., in check?
Any weightlifting protocol, as long as you're not doing these CrossFit exercises where they really kill themselves with the barbells and all these other weights and pushing tires and whatnot. I personally do. Basically, I do sets of push-ups only. They're actually a great core exercise as well. And I do 60 push-ups 3 times weekly. For me, that's more than enough. And the rest of it, keep in mind that there's some wild animals out there that have massive muscles and they don't exercise. Gorillas and chimpanzees are 2 great examples. Now, you can say chimpanzees climb trees, and yes, that's true, but gorillas, not really. They're mostly like a ground-living species, and they spend their days eating mostly leaves. Yet the males are, everybody knows the stereotype of the 800-pound gorilla. They're extremely muscular and extremely strong without really doing much of an exercise. It mostly comes down to keeping cortisol and stress hormones in check and doing some stimulating physical activity. Weightlifting would be fine, but I wouldn't get to the point where I'm spending 1 hour in the gym. I think 15 minutes to 30 minutes would probably tops of what you need. And if you're getting the sore muscles on the next day, you've overdone it. Taking some progesterone / DHEA is a great way to keep, in my opinion, the cortisol response and keeping you from entering a chronically catabolic state. If you're hypothyroid, exercise may not sit very well with you, and I would listen to your body. I would try to fix thyroid function first. You can actually really damage yourself by pushing yourself to exercise just because the doctor told you it will be good for you.
Ole, any advice on reading research for beginners? Do you know of any good resources to learn, and do you have any advice on what to focus on when reading?
Any good introductory book on biochemistry would probably do well. Any good introductory book on physiology. I think Ray has some recommendations. He said that the current book on physiology can really damage your mind. It's like teaching some very, very wrong things. He had a special article about this. I forgot like what it was called, but he said that most medical students learn physiology from an abysmally bad, old, outdated, and frankly wrong book. So I would just pick up like an introductory biochemistry book and go with it, because after it gives you the basics of learning the language basically and the terminology and the basics of metabolism, the rest of it would be mostly like you can actually on Khan Academy, which puts out these free videos. There is an entire library of physiology videos, of biochemistry videos, of videos of metabolism. So I actually spent about 6 months several years ago going through their database, and at the time it wasn't really that extensive. It had only about 50 videos. I think at this point it's more than 400. So I would check out Khan Academy definitely. So to summarize, good introductory book on biochemistry, Khan Academy, whatever they have, and then afterwards is simply reading studies. It's reading experimental reports. That's what gives you the knowledge.
You can't see it, Georgie, but I have Endocrine Physiology by Constance R. Martin, 1985. And Ray mentioned this book a long time ago. And I took it on a trip to Hawaii. It was like the stupidest packing thing ever because it's like a ridiculously thick book. But on the airplane, I remember just going through and highlighting all the stuff that Ray had said, you know, like trying to like match. I don't know if I think Constance R. Martin is a woman. I actually don't know, but like she says so many things that Ray says, like uncontroversially, and so she talks about estrogen and prostaglandins and prolactin and cortisol, and you can find some true gems in it. So. And also
can you send me a link to that book on the
like
chat on the
serotonin
Skype?
And ACTH and things like that. Yeah. So it was like a big deal when I remember reading it, because that was one of the first things that was supporting what Ray was saying, because I couldn't really understand his references when he would post them. And so this book is written in an intelligible way, at least for me at the time. And even if I go through it now, like Steph is pointing out how big the book is. And I just remember being blown away with how similar it was to Ray's perspective.
I guarantee you it's not being studied in medical schools. I guarantee you.
1985, yeah.
Yeah.
It's pretty cheap. It's like $29 on Amazon. So.
Wow.
Cool. Okay, let me change this back. Okay, here we go. Okay, where were we? Can I add in one more thing here? I think at least for me, it's been helpful to read things that were actually like outside of my pay grade. Like they were actually more difficult for me to understand, because I feel like, not that I understand anything, but like I feel like if you do that enough, you kind of will assimilate new information more easily than just, did you say this? Sorry, I was like not probably.
No,
not
I mean, it's like you just described the process of learning. Okay. If you're not challenged, how are you going to learn? But just stay at that level. And that's why children always like novelty, because after they learn something, like there isn't much challenge to it, right? Like you can't grow unless you challenge yourself.
Well, in Ray's From PMS to Menopause book, he says something like, people tell me they do not want to hear a lot of the technical stuff, but unfortunately, like the authorities who don't want anybody to learn the technical stuff are killing everybody. He says it way better than that, but
that book, by the way, it's titled greatly. I every feminist friend of mine that I showed this book to, they say it's so insulting. They will just like, for PMS to menopause, female hormones in context. They said it must have been a chauvinist writing this book. He's like, he just said that PMS is a problem. It's our hormones that are causing this. I'm like, why don't you read it first, and then we can talk about it.
I've never experienced that, but that's not surprising at all. Fun fact: one episode, I was asking him. I was like, Ray, has a feminist ever? Or I guess a certain type of feminist, obviously. I was like, have they ever confronted you in any way? And he was like, once at like a grocery store, I was attacked.
Wow.
And because I was like, I know that in the popular culture, estrogen is thought of as femininity. And of course, the argument is that that's not accurate. And then he told me this story. And I don't typically do this, but I actually like edited it out, because I was kind of like, it came off like real quippy on my end. and I was like, oh, I don't want this to like ruin this episode. But I ruined it in other ways. So yeah.
He also said that he was the original feminist until Gloria Steinem came along.
One of my episodes. Yeah, he mentioned that. CIA operative Gloria Steinem.
That's right, CIA operative. To this day, by the way. Like they asked her recently, and like first she refused to answer, and they said, well, look, you kind of have to, like it's important for the show. And she's like, well, once you get in, you never get out. Is that enough of an answer?
Okay, this one's from Bushido1, and they say, I have been trying to increase my cholesterol for the last 5 months by eating a PD diet composed of fruit, milk, beef, coffee, gelatin, aspirin, vitamins D and K, etc. Even after 5 months after following this diet, my cholesterol hasn't moved from 135. What else would you recommend doing to increase the cholesterol besides diet?
Well, some of these things will lower the cholesterol, specifically the caffeine, the aspirin, and niacinamide. But I would, if sugar is supposed to be raising it really easily, and so does saturated fat. If both of these are not raising it, then I would check liver function, because that's where most of the cholesterol synthesis happens. And usually people who have trouble raising the cholesterol, they find out they have a liver issue. And a liver issue can sometimes be easily corrected simply by using more vitamin D and calcium. I've actually asked Ray directly about it several times, and uncharacteristically, his response is always being uniquely identical, in which he said that, in his opinion, the deficiency of calcium and vitamin D are actually a cause of the liver issues and not so much of a result.
Tell me what you think about this, but I think part of the vitamin D and the calcium are to suppress the endotoxin, which is chronically interfering with the liver, producing low cholesterol. Is that right?
Yeah. Vitamin D is a TLR4 antagonist. It's a steroid, right? Many people don't realize that. And it has been shown to directly bind that receptor, which the endotoxin activates, and vitamin D actually deactivates it. Vitamin D and A have that function uniquely among the vitamins.
Sweet. This one's from Jeff Master. Thank you, Bushido, for that question. Jeff Master says, an 18-year-old friend has seronegative spondylotrophy reactive arthritis. I've never heard that. Who is currently on fortnightly injections of Humira and oral prednisone. What steps can be taken to reverse the ailment via diet and supplements, which I hope will assist in coming off these severe medications? Do you know what I'm talking about? Did I say it?
Yeah, actually, I mean, it's. I think it's considered similar to the autoimmune arthritis. Hence the prednisone. That's why, because it's an inflammatory condition as well. I wouldn't use any of these. First of all, Humira itself is potently immunosuppressive. If you look at some of the side effects, and they tell you even on the commercials, some of them include, actually some of the common side effects can include like getting a number of different cancers, and a really dangerous, actually lethal condition called PML. It's a neurological condition. It's a rapidly demyelinating neurological condition. So getting Humira in combination with prednisone, that makes it even more dangerous. And most of the arthritic conditions, especially if they're in areas that can easily be reached topically, has been shown, and the studies are still there. You can actually put somebody in a remission, and they used to do it by injecting progesterone into that inflamed joint. And if you can inject it, you can at least rub it on top of it. So if you have access to any kind of a liquid progesterone product, I would try to rub it around that area, and taking it orally, just so it has systemic effect as well. But even topically, it's going to absorb. So my recommendation would be that a combination of progesterone should be able to fully replace the Humira and the prednisone by having the same beneficial effects and not much of a side effect or risk. And also niacinamide is, again, I think it was a study I posted more than 5 years ago, showed that every single autoimmune condition, an inflammatory condition, has a deficiency of NAD at its core, and proposed agents like niacinamide that raise NAD, and methylene blue, which does the same, propose them as a generic supportive treatment for any autoimmune/inflammatory condition. So yeah, aspirin, niacinamide, methylene blue, and especially progesterone would be the things that I would try. And at least the latter one has extensive evidence, but it's mostly from studies done in the 1940s and 50s.
Sweet. Thank you. Jeff has another question. He says, someone in their 50s is diagnosed with terminal bone cancer. Is it possible to reverse this type of cancer? If so, what measures may help?
Aside from Ray's recommendation of like 12 to 15 aspirin tablets, I would actually, in this case, I would use the higher niacinamide dosage as well, because as I posted on the forum, several studies show that niacinamide can reverse and cure even pancreatic and liver cancers. Both of them were terminal, and pancreatic is probably even more lethal than the bone cancer that this person has. And the effects were that in higher dosages, niacinamide it does lower lipolysis, but it doesn't lower baseline lipolysis. But what it does do in the higher doses, by suppressing Sirtuin, that gene that's responsible for fatty acid oxidation, it actually blocks the fatty oxidation directly. So there may be a minor side effect such as buildup of accumulation of ammonia, but it can easily be handled by just taking the aspirin actually chelates ammonia, so this should be able to handle some of the ammonia buildup. And Ceylon cinnamon is a great chelator of ammonia because it contains something that metabolizes into benzoic acid. Benzoic acid is used as preservatives in many soft drinks. So even like a tiny sip of I don't know, not that I'm recommending like Mountain Dew, known to have benzoic acid, a number of different sodas can actually have a powerful ammonia chelating effect and handle even that minor side effect from the high dosage niacinamide. So I will do the high dose aspirin. I would add the high dose niacinamide, maybe 2 to 3 grams daily. And I would also consider progesterone, because most of the bone cancers and the hematological cancers that depend on bone marrow, most of them, the vast majority of them, have estrogen at its core. And anything that blocks estrogen may be therapeutic. There's a study on PubMed that recently was shown out that basically they gave the cortisol blocker mifepristone, which is known as it's also an abortion pill because it blocks progesterone, but its main actually effect is blocking the cortisol receptor. It induced rapid and permanent remission, and I don't know how permanent remission is different from a cure, in a rapidly advancing multiple myeloma, which is also a bone cancer, that was considered terminal. So not only it stopped it, but it made it disappear. And this study was published 3 years ago. This woman is still alive, I confirmed, and is no longer taking the mifepristone. So something about blocking cortisol and estrogen really seems to put the stop on those cancers.
Thank you for that, Georgi. Thank you. Who asked that question? Thank you, Jeff. Cam, quick one, says, can powdered gelatin replace bone broth?
Yes, if it's of good quality. Depending on the production process, some of them have some residual acid in it because they use acid to hydrolyze the bone and the protein. I personally seem to do well with the very cheap, widely available Knox brand of gelatin. So just make sure that when you take it, it's dissolved in warm liquid, like hot soup would do. I actually chase mine with orange juice, but I do it 1 packet at a time. The Knox gelatin brand usually comes in these boxes. They have 4 little packets inside. And I used to, like, in my earlier Petherian years, around 2011, 12, I used to basically open these 4 packets and dump them all into one sitting, and they get into this bowl, right? And a lot of it would basically come out undigested. Clearly, you don't want that. Yeah. So you need to, first of all, 1 packet is more than enough per sitting. And 1 packet is probably about half a tablespoon. So if you take 1 packet, just directly dump it in your mouth and take it with sufficient liquid, that's enough to dissolve it. But really the best way is to put it in hot liquid, because it then truly dissolves, and then you can eat that soup or whatever other hot liquid is. I think this will replace the collagen that's coming out of bone broth. But bone broth has other benefits, mostly coming from the fact that some of the bone marrow also makes its way into the broth. And bone marrow contains a lot of steroids. It also contains a lot of zinc, copper, and I think some of the rare metals like molybdenum, manganese. So those things the gelatin will not be able to replicate. But I've talked to Ray several times, and he thinks most of the benefit of bone broth is from the collagen. So powdered gelatin should be able to replicate that fully.
And something the vegan people point out that is the bone broth can be contaminated with lead. And so I think that's why Ray favors the oxtails for, I guess they're less contaminated than the big bones, I guess. I don't know. I have 2 papers on it, but
Well, anything commercially produced tends to have some residual either toxins from the production process.
But talking about like home making the bone broth.
Okay.
Not necessarily the grocery store stuff. I think the oxtail is preferable because you're cooking it. Again, it's getting down to the nitty gritty, but I think because you're cooking it for 3 or 4 hours versus the bones that you're going to be cooking for like 24 hours, and that's going to release some of the lead.
I see.
So it sucks because bone broth is becoming so popular now. Like even in Mexico, there's like 2 different brands of bone broth, but because I'm crazy, I don't buy it because I'm kind of worried about the lead content.
And also the prions, like those dangerous proteins that cause mad cow disease, they're much more likely to be in the bone.
Oh, really? Okay. Well, another thing. Okay, this one's from Ryan. He goes, this is a little bit of a long one. He goes, in a herb doctor's interview with Ray, he says, one of the problems with vitamin E is that it can preserve the amount of PUFA in the tissue, so it's important to keep the polyunsaturated fats down, as well as using the vitamin E to block the effect as far as possible. My question is, if you're in a state where your tissues are fairly saturated with PUFA, and you want to displace them from your tissues by using things like coconut oil and eating a low PUFA diet, would it be helpful to stay away from supplementing vitamin E during this period of time as to not preserve the PUFA in the tissues?
I think one of the ways vitamin E preserves PUFA is because it's also a potent inhibitor of lipolysis. So if you want to get rid of the PUFA, in addition to the to trying to displace it with saturated, by the way, longer chain saturated fats work better than coconut oil. So palmitic and stearic acid displace the PUFA much better because some of the shorter chain, like medium chain triglycerides that are found in coconut oil, they're very quickly oxidized. So you don't get as much chance for them to even make it to your tissues. They're oxidized just as easily as sugar, and then basically not much unless you take in massive amounts. So it takes longer to saturate your tissues with the medium chain triglycerides than it does with the longer chain fatty acids such as palmitic and stearic. So like eating the beef tallow or butter has some decent amount of stearic acid. Dairy has a decent amount of stearic acid and palmitic acid as well. So aside from that, basically, so vitamin E is mostly helpful while you have elevated lipolysis because, first of all, it's going to limit the lipolysis, and second of all, it can directly deactivate some of the PUFA that's floating around in the bloodstream. So I don't think you need to completely cut off the vitamin E. I wouldn't, if you look at some of Ray's recommendations recently, he's been telling people that they've asked him like, well, if I want to burn that PUFA, and I know you're telling us not to, but I'm exercising, what can I do to protect myself? And his response always is, even 50 international units of vitamin E should be enough to neutralize most of the PUFA floating around in your bloodstream when you're exercising. And that's a high amount of PUFA. You're under stress, adrenaline's high, right? You're under excessive lipolysis. So if that's enough during exercise, I would say much lower doses of like probably even 20 international units would be enough for a person trying to lose/displace it and without inhibiting lipolysis too much.
Yeah, that's interesting. I didn't catch that, the 50 IU. I've heard him say 100 before, but that's it's funny, his recommendations like decrease over time.
Well, he always cautions it when he gives lower dosages that these last recommendations, he was concerned about the quality of the vitamin E product. He basically said like, again, like, oh, I've never had like something that came close to the quality of that vitamin E. He's like, my experience with vitamin E has always been negative, more or less negative since the 70s. So if vitamin has to be used, I wouldn't take more than 50 IUs to like, it should be enough to, I think he's recommending the minimum that he thinks will help neutralize the effects of free-floating PUFA if it's elevated beyond a certain level.
Sweet. Thank you for that question, Ryan. Ellie says, how to protect oneself from EMFs and how to reduce EMF sensitivity. You're looking at real-time EMF protection right here, people. I don't know. We've talked about this, Georgie. What do you think?
So there was a discussion on Reddit about how EMF really hurts the organism, and one of the world's premier expert got absolutely slaughtered by the Reddit community, even though they are the ones who invited him. He basically, every time he tried to say something, his responses got downvoted into oblivion. So I can send you that discussion and you can provide it on the channel. But like, if you want to find his responses, you have to actually, you know how Reddit allows you to only see like the first 100 comments, and you have to click like show more and show more and show more.
Yeah.
His responses are like at the very bottom. Like everything else is like other people's comments, essentially bashing that person. Poor guy. I think he's at the University of Toronto. Anyways, so he was saying that the primary effect of EMF is inhibition of oxidative phosphorylation, and his take on this was that EMF does this by the activation of the calcium channel. So his recommendation was, well, first of all, stay away as far as possible from sources of EMF like the power lines in your walls or the Wi-Fi router, because the amount of exposure decreases as the square of the distance. So you really basically, if you have a Wi-Fi router in the room and you're sitting, let's say, 10 feet away from it, it's probably okay. But you can further limit the damage by taking magnesium, which is nature's natural calcium channel blocker. Selenium is another good one. There's specific studies on PubMed showing selenium prevents fully some of the negative effects that EMF has on male and female fertility, on cognitive function. All of these are in animals, but selenium seems to work rather well. And I know Ray has recommended cyproheptadine for that specific reason, because it's also a calcium channel blocker. Somebody asked him about sensitivity to EMF, and Ray said, well, if it cannot be avoided, I would consider something like cyproheptadine because of its calcium channel blocking properties.
Sweet. Yeah, I mean, this one's a difficult one. I'm actually thinking about replacing this with aluminum window screen, and so it's actually cheaper. I think it's probably more effective, and the only thing these walls are I don't even know what they're made of. They must be made of rock or something, but I can't even nail in something to them. And so I might try to staple it to the walls to see what happens. There is a channel I follow that's just basically on EMFs, and they have a new meter that was showing 5G, and they weren't even aware of 5G in their area, and they were getting blasted with it on their new meter. And the only thing he could put together was there was a military base not too far away. And so his hypothesis was they must be messing around with 5G because and the meter was going crazy.
Going nuts, yeah.
So it's really something that starts, at least for me, being real when you were able to measure it and then hear the sounds that the meter is making, because it's
and by the way, keep in mind that most of these meters, they're set to start giving the alarm off at whatever limits the EPA or CDC has defined.
Yeah.
The scary part is that most of these studies are done with exposure that's less than 100th of that limit. Yeah. So it's if your meter is going off, you're not simply above the acceptable level. You're actually really above the acceptable level, because even the acceptable level is already too much.
You're right. And I forget what it's called, the Bio Initiative report, and they say exactly what you just said. I think Steph knows. I'm pretty sure Steph and I have talked about it too. But it has a paper on I'm totally forgetting how it's measured, but it's 0.1, and that's that's the second level on my meter. But seldom does it ever go there, even with shielding, So this is something that's, I think, challenging.
Speaking of shielding, are you familiar with the HECS clothes for hunting? It's spelled HECS.
I think you talked about it before, but I don't know much about it.
I stumbled upon somebody posted a video on the forum, and it was really long. It was an hour and a half, how to protect yourself from EMF. And then guy went through a lot of things. I didn't have an hour and a half to watch the whole video. It was starting to get really boring. He was talking about his rifle and his hunting habits and whatnot. But I just kept basically skipping, and eventually, just by accident, I ended up cause he's a hunter and these are hunting clothes. And apparently because they block, so we also emanate EMF, right? It's just it's relatively weak, but animals can pick up on that. Mm-hmm. And they selling these clothes to hunters because when you're dressed in these clothes, they have these cool videos on YouTube. You can actually walk and stand right next to a brown bear, and I don't know why would you want to do that.
I've seen this. Okay, keep going.
Or a bobcat or something, and they can't detect you. They see you, but they think you're an oak or a rock or something because you don't have the proper EMF signature. Anyways, that guy basically has some cool videos where he shows that he only bought the undergarments, or not bought, but he only uses the undergarments. They have underpants, undershirt, a hat, and like a jacket and pants, right? You don't need to buy the whole thing, but it does seem to block most of the EMF that's basically blasting at us from all directions. And so I've seen them on Amazon. They're actually, at this point, there are even Chinese knockoffs available on Alibaba. So if you don't feel like spending $100 on these clothes, you can get them for $10.99.
Okie doke. Okay, so let's do what how long have we been doing this? We're at 2:30. Okay, we got 30 more minutes. Or really however much time we want. George says, have either of you guys looked at Matt Stone's buddy, Dr. Garrett Smith's stuff on vitamin A toxicity? Your thoughts would be appreciated.
I don't know if this related to that thread we had on the forum.
Directly related.
Yeah, I don't think vitamin E toxicity is such a problem as it was made out to be in that thread. Keep in mind that many people, especially if you have like dermatitis, like basically if you have dandruff or any kind of a skin problem or eczema, this is actually related, aside from estrogen excess, it is related also to vitamin A deficiency. And vitamin A, together with vitamin E, are the two endogenous, one of the two endogenous cardinal protectors against estrogen, progesterone being the other one. So I have never seen a person with true vitamin A toxicity, despite knowing several people who take several 100,000 IUs daily. One of them has a he had a cancer scare. His doctor thought he's developing leukemia. So he thought, like, why not try this, the vitamin A, the high dosage regimen. So all of them are taking it with a little bit of vitamin E. So even 400,000 international units daily of vitamin A palmitate did not cause any toxicity. So the whole thing about vitamin A somehow, causing all of these, bizarre symptoms that were described in that thread, and one person solving all of their problems by simply restricting vitamin A, I don't think this is accurate. I mean, vitamin A toxicity has some very bad signs. One of them is increased intracranial hypertension. So you can get a brain herniation if you're truly vitamin A toxic. You can die from it. These symptoms are unmistakable. You start getting gait problems. You can't lift your arms up. Like, you start getting these myopathies. Your muscles are starting to break down. Your creatine kinase, the enzyme in the blood, gets really high. All of these are unmistakable signs of vitamin A toxicity, can easily be diagnosed. And actually, doctors are very well aware of them. What you could have is a buildup of beta carotene, which will show up as getting your calluses on your hands and feet getting, turning into an orange color. That is a problem, but that's not vitamin A yet. Beta carotene is a highly unsaturated molecule that doesn't have vitamin A effect. It has to be converted to retinol. And that itself, it's a powerful suppressor of the thyroid and has a potentially carcinogenic effect in the lungs. So that may be a problem. Getting vitamin A toxicity of a preformed vitamin A that you get from food in the form of retinol palmitate, retinol acetate, or by eating liver, I have not seen a single person in my life that ever had that issue. Most of them were actually deficient, not toxic.
My gut feeling are people are synthesizing things wrong or misinterpreting things about their own state of health. Like we talked about iron overload earlier, fatty liver. Like I think there are things being not addressed. And how do you say his name? Grant Giroux or whatever.
Which one?
He's the kind of inventor of the theory.
Yeah, it was some French name. There's a thread on the forum posted, and it was one engineer who apparently solved all of his problems simply by restricting vitamin A. Well, he didn't measure anything. How did he know that he actually went into a state of vitamin A deficiency? How do you know?
Well, again, I don't doubt that lots of people are hypothyroid, and so like not taking a bunch of vitamin A. This was like the weirdest thing to me, because Ray has addressed this so many times that that vitamin A could be a double-edged sword, and so that's why I was like, people are saying he's wrong, like really wrong about this main thing in steroid synthesis. It's confusing because he's already addressed his point of view, saying that he's perfectly aware that it can suppress the thyroid and it's an unsaturated molecule or whatever, and can degrade with the PUFA and like a lipid peroxidation type process or something.
But that's why I mentioned the vitamin E. Like the studies have specifically addressed that angle and showed that, let's say you take like 100,000 IUs daily of vitamin A. Adding just 100 IU of vitamin E to that was able to completely prevent any toxicity and any anti-thyroid effects. So it's really the unsaturatedness of the molecule that may be an issue here, but even massive doses. And in fact, in Russia, there's a drug that they sell for preventing cardiovascular disease. You know what it contains? It's these tiny little pills. I will bring them next time. I bought it from like a Russian website that sells like old school Russian drugs in the United States. Like it's called Babushka store, which means old grandma. And basically they come in these little gel caps, and they have 200,000 IUs of vitamin A palmitate combined with 100 IUs of alpha tocopherol acetate. And that has only about 50% of the vitamin E activity of real tocopherol. So you're really getting only 50 IUs of vitamin E. And that drug is used in Russia to treat / prevent cardiovascular disease. And it has, if you look at the side effects, basically they're saying it's completely safe. Even unless you have cirrhosis, I guess, that's the only caution that they have. And there are no reports on this ever causing problems to anybody. And people with cardiovascular disease are already hypothyroid. If anything, they should be seeing any, side effects and problems come up.
Yeah. The last thing I'll say on this, and you can probably relate, is when you talk to lots of people and they say, hey, I'm dealing with a very serious health problem, and you start sparring and not sparring, it's like throwing out ideas, you quickly find that some people are incredibly resistant to different types of ideas. Like they specifically don't want to do that.
Right.
And it's not, I'm sure you feel the same. It's not my job to convince person XYZ to do the thing they don't want to do. And sometimes over time, a person will warm up to different things, But again, that's kind of what I think about when, again, these people are saying, oh, it's like, I've tried so many things, but now this miracle cure, it's like.
Exactly. It usually doesn't work like that. So it's just like, it's like if you have an issue, it usually it's not some obscure little thing that you spend 5 years looking for and finally it's almost like the cancer industry's hunt for that unique enzyme that it's so unique, only a patented drug can inhibit it, and then suddenly you're miraculously cured. No, it's usually something much more simpler and generic, right?
Yeah.
So we should be working towards the direction of what are these simple things in your life that you're doing that are really hurting you, instead of looking for a scapegoat in some obscure vitamin or strange chemical that you thought may have been exposed to like 10 years ago.
Yeah, well said. Okay, moving on. Cornelius says, does Georgi have any thoughts on how to treat pericarditis? Pericarditis?
Pericarditis, yes. Yeah. It's actually directly caused by endotoxin. Even in some countries, actually now they treat it with antibiotics. Actually, the standard treatment is antibiotics, but they found out it's not because it treats the bacteria that's there in the inflammation. It's because it actually lowers the endotoxin load, the endotoxin exposure. And since it's the endotoxin causing this, some drugs that have been found to miraculously work because medicine doesn't want to admit that it's endotoxin that's involved are the drugs like ketotifen and cyproheptadine. Both of them are antagonists of TLR4, and ketotifen also blocks the leukotriene receptor, and leukotrienes, which are PUFA metabolites, are also known to be involved in pericarditis.
Sweet. Cornelius has another one. He says, given that allopregnanolone is currently being looked into by pharmaceutical companies for depression, Alzheimer's, Parkinson's, and virtually every other neurological disorder, what are the best ways to raise allopregnanolone without directly supplementing with it? What are the best alternatives? 5-ADHP, DHEA, pregnenolone, progesterone. Ray, in his latest article, showed that like 20 milligrams of progesterone increased allopregnanolone by like 157% or something.
So there were also like studies with people with schizophrenia. They gave them these massive doses of pregnenolone. They gave them 500 milligrams daily. Well, I shouldn't say massive. I mean, Ray took several grams daily for years. So, but anyways, for doctors, it's considered a massive dosage. And then it was shown that most of the pregnenolone went towards raising the levels of pregnenolone first, allopregnanolone second, pregnenolone sulfate, and progesterone. It didn't really raise that DHEA that much. It was slightly bit of raise. But anyway, so pregnenolone for most people is apparently a reliable way of raising allopregnanolone just because it's a precursor. So is progesterone because actually even one step closer. In some people, so a small subset, people who have taken finasteride or some of these other 5-alpha reductase inhibitor drugs, some of these people seem to actually have a deficiency of the enzyme 5-alpha reductase, whether by function or actually expression / levels. In those people, you may actually need to take the preformed allopregnanolone or an already reduced precursor like 5-alpha dihydroprogesterone. But these should be in the minority. For the vast majority of people, pregnenolone and or progesterone should be perfectly sufficient.
Sweet. Thanks, Cornelius. Tim says, I know from a bioenergetic standpoint, the exhaustive exercise is at best maladaptive. That said, if one chooses to voluntarily compete in such endeavors, what countermeasures does Georgi recommend both before and after exercise? Supplement suggestions are welcome.
Well, we just discussed one, vitamin E, and Ray specifically recommended to people who are thinking of running or doing some kind of like a quote-unquote endurance exercise because you want to limit the negative effects that PUFA has once they hit your bloodstream. I don't know if you remember that study I posted on the forum that basically by the time they completed a marathon, 82% of people who were in the marathon had temporary kidney disease, had kidney failure. They were in early stages of kidney failure. It was considered acute, and many of them / most of them recovered, but no studies actually did a follow-up with them and see how they did later on. Did this turn into a chronic kidney disease? Anyways, the damage is done mostly by the elevated free fatty acids. Most of them are PUFA. So anything you can do to limit lipolysis or neutralize PUFA, so niacinamide, vitamin E, aspirin is a great one, and a little bit of methylene blue just to keep lactic acid at bay. Lactic acid is also a universally recognized mitochondrial toxin, and it's responsible not just for your muscle pain the next day. It also contributes to so-called central fatigue. The realization, the feeling that you're tired, you're done, you don't want to do this anymore. So a little bit of methylene blue about maybe like 30 minutes before, vitamin E anytime really before the event up to like 2 days before, because vitamin E has a really long half-life of like 48 to 72 hours. And then aspirin, you can be taken with a methylene blue maybe like 30 minutes before the event, and one tablet should be enough, and just a few milligrams of methylene blue.
Thank you for that question, Tim. Vanessa says, can we please talk about sleep? What are the things that can be used to improve sleep or actually get sleep when antihistamines or the sugary, salty foods no longer work? What other things can we do to help with sleep?
I have received reports from several people that, well, first of all, thyroid is known to work. Progesterone is known to work for a number of reasons. It's a GABA agonist. And actually, antihistamines are not that good as a sleep measure because as a sleep inducer, because yes, they do make you sleepy, but they don't necessarily promote sleep. They should make you tired. And what happens is that they also have a tendency to actually elevate adrenaline. So histamine and adrenaline really are opposing forces in the body. It's not a coincidence that for allergy they give you the EpiPen. You're injecting like an adrenaline-like molecule to stop histamine from working. So some antihistamines can not paradoxically, but they can actually elevate adrenaline. So you'll be tired but wired, and you don't want that feeling. In my experience, progesterone works much better, and what also seems to work is a lower dose pregnenolone. There were actually one of the earliest studies with pregnenolone were on improving sleep, and believe it or not, they used a tiny dosage which turned out to work remarkably well. It was just 1 milligram. About an hour before bed, and improved everybody's sleep. So 1 milligram of pregnenolone apparently is enough. And I think mostly because the lower dosages convert very easily to allopregnanolone, and that's like the major inhibitory neurosteroid in the brain. That's allopregnanolone. And methylene blue, like just 1 or 2 milligrams before bed. I've personally experienced it. Other people have confirmed it. It not only lowers lactic acid, but it increases the production of carbon dioxide and carbon dioxide has a sedative, calming, hypnotic effect. And methylene blue also has an anti-cortisol effect at the receptor level, which is not very strong, but still apparently potent enough to affect sleep in a good way.
Sweet. The only other thing I would add is, you probably said it, but the vitamin D I think is important.
Oh yeah.
Thank you for that, Vanessa. Okay. Maybe we should start these earlier.
Yes.
So that'll be something we'll talk about immediately after this. I'm like dozing off. Okay. We don't have that many questions here. Mark says, Georgi, on Repeat Forum, you posted a Reddit link about the effects of EMF on health. Do you have an opinion on so-called PEMF, pulsed electromagnetic field therapies or devices? It seems to have to do with something called the Schumann resonance, trying to mimic them and such. All I found so far was Repeat expressing some support for grounding and earthing mats. Apparently NASA is working on this right now.
I don't know much about it, but in general, I'm skeptical about electromagnetic therapy for like health reasons. I would say like avoiding the exposure is very important, and you don't need actually to. So that PEMF. So the Schumann resonance, you should be exposed to it no matter where you are. It's just part of the Earth's frequency. Actually, that raises a good point. I remember reading a study recently, and they put rats in Faraday cages where all of the EMF was completely blocked, including the Schumann resonance. And actually, rats did not do well health-wise. But as soon as they introduced the device inside the cage, that was producing these low frequency, I think they're like 40 to 60 hertz. Mm-hmm. The rats were doing much better, and they were doing better than the rats that were on the outside. They were exposed to all kinds of EMF. So I personally would stay away from EMF therapy. We don't know much about it. I think many people are aware of Ray's articles about the Russian studies they did with radar, like people that were basically like the radar workers who are both working close to radar or help deploying it, can actually kill you pretty reliably depending on the wavelength. I think if the wavelength is twice between 1.5 and 1.5 and 2 times the radius of your head, can actually directly kill you by heating up your brain too quickly. And in general, EMF, like it's just by being an inhibitor of oxidative phosphorylation at all frequencies except the very low ones like the Schumann resonance, I would love to see that strong evidence that shows that they're beneficial. In my experience, there isn't such evidence. They're actually mostly harmful.
Linda says, could you please review if there is any kind of formula for comparing all thyroid levels? If TSH is X, then T4 should be Y, and then T3 should be Z.
There is no such formula. There's only formula for converting approximately T4 into T3. So you basically get that, T4 is only 1/4 as active as T3, but it's misleading. It's a misnomer because by itself T4 doesn't have any thyroid effect. It's just that only about 1/4 of the dosage taken converts into T3. That's really what it's based on. But it's also misleading because that's not a rule for everybody. It depends on your actually thyroid function. It depends on your liver function. Depends on your estrogen levels. Like a postmenopausal woman that is in relative estrogen excess and progesterone deficiency, her liver won't be working very well. So T3, the effectiveness of T3, in my experience, remarkably declines with age. So while in a young person, let's say like 100 milligrams of T4 may be equal to 25 milligrams of T3, in a much older person, 100 milligrams of T4 may be equal to only 5 milligrams T3. So it really isn't any formula. And besides the response of TSH, of the response of the thyroid gland to TSH, it's also varies tremendously from a person to person. It depends on factors like parathyroid hormone, like vitamin D actually, depends on cortisol. Cortisol actually suppresses the response of the thyroid gland to TSH. If you're under stress, your TSH will jump tremendously, but if cortisol is also high, you will not be producing thyroid. It's well known that people under stress have high TSH, and it's baffling endocrinologists like why isn't there like a corresponding surge of thyroid hormones? Well, it's because the thyroid gland is actually blocked by cortisol.
Yeah, so she finishes up and she says she just had a thyroid panel done, and the reverse T3 is high. And I would echo what you said. It would be great if there was some formula, but the sad truth is that if you use some formula like that, you're likely to go in like a completely wrong direction. And the symptoms and the temperature and pulse are, to me, the most important things.
Yeah.
And the Broda Barnes was kind of the person that wrote about that the most, and thinking about the symptoms and the person's, well, specifically their underarm temperature, rather than these, while they can be important, they're not necessarily instructive.
And the Achilles tendon reflex.
Yeah.
Actually, in general, nerve/muscle relaxation is a huge indicator of thyroid function. Like if you get muscle cramps, aside from electrolyte imbalance, the second most common thing is hypothyroidism.
Sweet. Okay, Mark Jones says, my question, thank you, Linda. Mark Jones says, my question is, do you think that collagen hydrolysate is, we answered this exact question a while ago, right? Whatever. Do you think collagen hydrolysate is as useful and safe as gelatin? Probably not as
I would
safe,
say,
but it can be useful.
Exactly. Not as safe. It will be more easily digestible, but keep in mind the hydrolyzed collagen has been produced with acid. And many times there is residual, some very toxic heavy acids. That's one of the reasons Ray doesn't like vitamin C supplements. He said that all of them are produced, I think they have residual sulfuric acid or I think, what do you call it? Perfluoric acid was even stronger and much more toxic. So that's why he stays away from vitamin C. And I know that some of the collagen, hydrolyzed collagen, is produced with really toxic organic like acids that are themselves contaminated because they were used for some other industrial process.
Yeah, and just a tip, like if you're going to use you apparently are not affected by this, but I have to totally dissolve any type of gelatin I'm going to use. So I will like boil water, even if it's gelatin hydrolysate, and I'll boil it down and really mix it so there's no like floating things. But
yeah, I mean, I'm the same way. If they're little nuggets that are clumped together, then yeah, it does affect my digestion. That's why I said I used to like dump the entire Knox gelatin box. That's too much, right? And immediately turn into a little ball. And I chewed on it, but then it turned into a chewing gum. It's like, the more I chew on it, it just turned into this undigestible, unchewable material. Eventually I swallow it, but then it just doesn't digest. So less gelatin per dosage several times throughout the day is much better than like a bigger bolus dose.
I totally agree. Linda also has, can you direct me to an interview or article from Dr. Ray Peat about prolactin and parathyroid levels, how they have changed, and what good result for either is? I feel like I'd have to like email.
There's so many, but I think like one of the main things that he said that, and I've confirmed that like the normal ranges for prolactin have been changing consistently over the last 20 years. And every time they change, they raise the upper limit and they're saying like, oh, I think right now for males, like the upper limit of normal is 20. Mm-hmm. Like 15 years ago, you'll actually be considered severely hyperprolactinemic, probably being sent for an MRI to check your pituitary and things like that. And like I think 15 years ago, the upper normal range was 11. So it's like almost doubling the normal range.
Yeah, I don't talk to anybody that doesn't have a level of around 10. And then I forgot the paper, but there is one that talks about hardening of the arteries with parathyroid hormone in the middle. And so, again, just trying to get that as low as possible, basically.
Yeah.
Sweet. Okay, 2 more questions. RJ Edwards says, I feel like this may have been discussed in an earlier show, so forgive me, but I'd like to talk about phosphorus. If a person consumes a lot of dairy, they are likely to also consume a large amount of phosphorus, which Pete warns against. Is this a problem, or does the calcium content of milk protect against it? Is there an upper limit for phosphorus intake? And Ray specifically mentions this in his milk article, that the balance of phosphate and calcium in milk isn't like extraordinarily high. But then if I remember correctly, he talks about like epidemiology and milk being favorable for bone growth. And I think he says cheese might be a better source of protein in the long run. But what do you think?
Yeah, and also, so first of all, it's the ratio that matters, right? And if you're eating meats, you're actually getting almost no calcium, most phosphorus, right? So steering away from the foods that have ratio in favor of phosphorus is probably like the first good step. Second one is like if you really want to lower your phosphorus, your phosphates in general, fructose, sugar, sucrose in general is a great way because fructose lowers it. It's known to lower it. And niacinamide is a great tool to lower it. And for that reason, is used in several clinical trials for people with chronic kidney disease. They tend to have very high phosphorus, and it's one of the factors known to be involved in the actual kidney damage. So even as little as 200 milligrams of niacinamide was shown to be effective of lowering phosphate.
Yeah, Ray says in his milk article, he goes, since milk's primary biological function is to support the growth of a young animal, some of its features make it inappropriate as a sole food for an adult. To support cell division and growth, the methionine and tryptophan content of milk is higher than would be optimal for an adult animal, and the phosphorus might be slightly more than needed in relation to the calcium. Since the fetus stores a large amount of iron during gestation, the iron content of milk is low. However, for an adult, that was... basically it. But I mean, if you yeah, I think you answered it. The fructose helps deplete the phosphorus. And then I don't think he has any qualms about taking in like 2 or 3 quarts per day. He told Bud Weiss that he often gets like over 3,000 milligrams of calcium per day. And so if he was taking that in from milk, it would probably be like a fair amount of phosphate. But there was one article that said like I'm sure you've seen it, but it was like phosphorus is a problem for healthy people. And they were talking about how you could get a certain amount, but again, I don't know how that factors in.
Yeah, it's not that difficult to lower your phosphorus. Just avoiding those foods, like I said, and the niacinamide is a great tool. And if you're eating enough carbs, then you probably don't need to supplement with anything else. Fructose is great at lowering phosphorus.
Sweet. Wrapping up, last Patreon question. This is from Dan, and they say, if we take more than 1 to 2 milligrams of vitamin K, MK4, the next morning I have veiny eyes which dissipate over the day. Wondering why this might happen. Hypocalcemia. I've also been seeing veiny eyes correlate with higher estrogen. Would love any ideas what you might suggest.
Actually, what should I say? I mean, I guess they are correlated, but one of the main causes, at least in animal research, of veiny eyes is endotoxin. And or nitric oxide, because it's such a potent VEGF promoting factor, vascular endothelial growth factor. Lactic acid is another one. So I don't know why vitamin K will be causing this. It shouldn't. Maybe because it is a cofactor for many of the bacteria living in the gut. It has been shown that people with SIBO and severe gut dysbiosis, they actually may experience some side effects related to vitamin K. Those side effects were only seen with the high dosages, like 45 milligrams that they used to treat osteoporosis in Japan. So a few milligrams shouldn't cause that, but those would be my first guesses, because veiny eyes in that order are usually endotoxin, nitric oxide, lactic acid, and or estrogen. Maybe some blood tests could do that. I posted on the forum. There is now it's been around for a while. There's actually a blood biomarker for endotoxin. It's called soluble CD14, SCD14. If you Google the forum, if you search the forum for SCD14, it will come up.
Sweet. Thank you for that. I forget just closed the window. Who is that person? Oh, that was Dan. Thank you for that question, Dan. Okay, get through the super chats, and then we'll be done. This was a long one.
Wow.
Okay, Heighten Living. Thank you so much. Heighten Living has a channel. You guys should go check out. I think he has some excellent. He interviewed some Ray Pete person. I forget their name, but it was a good interview. He had $5 for super chat. Thank you so much. Sincerely appreciate it. Brandon Treen for $10. Thank you so much, Brandon. He says, if cortisol is high from dysbiosis, would cortisone transdermally be a wise tool for regulating sleep? Any other suggestions to improve uninterrupted sleep? Thoughts on liposomal colostrum for gut repair? So first thing is about cortisone to regulate sleep, and then any other suggestions, and then liposomal colostrum.
Well, I think cortisone should work, right? But if there's a known problem with dysbiosis, That's what I would try to address first. So, right? I mean, if cortisol is elevated because of the dysbiosis, you kind of don't want to be opposing cortisol in that specific case. It's elevated for a reason. So maybe try a little bit of the antibiotics, see if that helps. I think apple cider vinegar was recently shown to help for SIBO. So I guess if there is a bacterial overgrowth in the small intestine, that may help. Progesterone actually has been shown to increase the production of gastric acid, and that has been shown to reliably reverse SIBO, or stop it. And if it's an issue with the colon, basically I think antibiotics would be my first bet. So I would leave the cortisone for last, believe it or not. I know it's my product and I'm supposed to promote it, but it does sound like in this case there is a good reason for cortisol to be elevated, and I would try to address those gut dysbiosis issues first. And the colostrum, from what I understand, it's mostly used to fix existing damage in the lining of the intestine, in the walls. And I don't think the gut dysbiosis, it shouldn't be severe enough to be causing that, because if it does, it can cause other tissues like peritonitis. So those are serious conditions. So I don't think I don't think the colostrum is warranted, because from what I understand, it's mostly used to repair an actual damage in the intestinal wall, and that shouldn't be happening in this case. So I would try to simply address the bacterial overgrowth, either antibiotics or increasing gastric acid production. Apple cider vinegar, aspirin seems to help too. Things like that.
I might be half asleep, but did you mention the liposomal colostrum?
Yeah, colostrum. Yeah, I just said the colostrum is used to repair damage in the. What did I say?
No, I was tuning out, so I'm so tired.
Yeah, the colostrum is used to repair an actual damage in the intestine, like people that have ulcerations or actually holes in their intestine. I think that's when usually colostrum is very helpful. Okay. Not so much for the dysbiosis.
Okay, it's 2 hours ahead from Pacific time. What in Washington? It's the same, right?
It's midnight.
Oh, okay. It's even later for you, and I'm zoning out. Okay. Yeah. Okay. Yeah, we'll definitely have to change this time. Wales says $5. Thank you so much. If someone has optimal thyroid function, can their pulse drop below 75 at any point in the day, or is low pulse exclusively a hypothyroid issue?
Low pulse can sometimes happen adaptively. If your thyroid function is high and you're exerting yourself, you can actually get first it will rise, but because the body tries to protect you from too much of a tissue breakdown, then you can actually adaptively lower the heart rate after about the first maybe 10 to 15 minutes of this strenuous event that you're incurring. But if this is happening on its own without any external influence, then it's probably due to some sort of something triggering a drop in the blood levels of T3. It shouldn't be happening on its own. If it does, in a person in good thyroid function, it usually happens as a result, as an adaptive downregulation to a strenuous event. And if that's not the case, then it's probably thyroid functions simply going down. So it's not that good to start with.
Okay, thank you for that. $5 super chat, Wales. Appreciate it. Israel de Leon for another $5. Thank you so much. Any thoughts on using chlorine dioxide as an antibiotic?
I think it has some very good evidence behind it. I think it could be dangerous. I've seen actually more evidence on it for cancer. It works similarly to hydrogen peroxide. So it increases reactive oxygen species. And it also works as an oxidizing agent. But I've seen some people use it very successfully to treat their animals, like if they have a bacteria infection, especially in the GI tract. And I know there are people out there on the internet publishing protocols for using it on humans. I personally don't have much experience with it. If you go by what the reports on it are, it does seem to work. It's just that there isn't much human data on it. But it does seem to work extremely well in animals. It comes down to controlling the side effects. And I'm always wary of molecules containing chlorine.
Sweet. Angelique Guasino for $2. Thank you so much, Angelique. We appreciate it. And Ray appreciates it. Tyler DeRoser, I'm probably butchering his last name. Thanks, guys. Always enjoyable for $5. Thank you, Tyler. Tyler is like an OG Ray Pete person, so it's like fun to see him around. You know, I think honestly, like 2011, probably before that. So great seeing Tyler. And Steph making it rain with the $31.41. Thank you so much, Steph. Yeah, it's not only that you're the best flipping mod, but you're also extremely generous. So thank you so much. If you have super chats, this is the time to do it. I'll just remind everybody one last time that we're giving away another bottle of the Tocovit. So please subscribe to the channel, like the video, and then leave a comment. Let me bring this up one last time. So this stuff right here, and I'll randomly pick another person. And Miles, please get in contact with me so we can send you your bottle of Tocovit. Any last parting words, Georgi Dinkov?
As Ray once said, keep fun up and stress down. And trust your intuition and make sure like basically I'm more optimistic about the world in the last year than I was like a year before or like in the previous 5 years. I think we're finally starting to see some good change, at least in medicine. Like the articles on treating cancer as a metabolic disease are one of the biggest signs. If people working for Harvard University, which was the bastion to this day continues to be of genetics, if they came up with a study that treats brain cancer as a metabolic disease and they openly called it such, I think we're finally seeing the tide is changing. I don't know how long is it going to take, but at least we have evidence that with persistence and keeping an open mind, we can find solutions to problems that even the experts are baffled at. And maybe that's really the way to be. It's like, don't be an expert. Maintain intellectual humility, as that article said. Open-mindedness and having fun, leisure, playfulness. Right? These are all apparently very, very serious things. It's just nature made them fun for us so that we crave them. But at their core, they're indispensable for the human existence, for the human condition. And the more you engage in them, the healthier you'll be, and the more protected you'll be, both from harmful chemicals and harmful people, and in general harmful events in your life.
Speaking of fun, definitely the most fun I've had doing this, even though I'm a little bit sleepy. So Georgi, thank you so much. Thank you, chat. Thank you for everybody listening to this after the fact. Again, the response has been overwhelmingly positive, and so I've been seriously looking forward to every single one of these I've been doing. So hopefully the show just grows, and just liking and subscribing and stuff. It sounds stupid, but can really support the show and that algorithm and how many people see it. So thank you guys so much. We'll see you when will we see you? The 28th of June again for a fresh new show. Thank you guys. From the bottom of my heart, always a total pleasure. Thank you again, Georgi. You're the man. Such a good friend. Thank you, Steph. And thank you to all the other mods that jumped in here. So see you guys soon. Enjoy this great music.
Thanks for having me.
Just a minute. We're still...